Good afternoon to you all. It's my pleasure to welcome you to the 11th edition of the Open Day of CTM. We are very pleased to have you here to discuss a topic of great interest, which is the convergence between high-speed communications and machine perception, and to share your insights, your perspectives, your knowledge, and also to try to see what are the opportunities that this convergence between these technologies can unleash in order to try to tackle the major societal challenges that we have nowadays. So over the next hours, we'll be hearing from a number of experts in the fields. We'll challenge you to think differently and to try to get a deep knowledge and analysis of the subjects. And we want you to participate in an active way, to ask questions, to share your insights, and make this event more perspicuous for all of us. So thank you very much, and we hope that you enjoy this event. And so let's get started, and to do that, I am honored to invite Professor Rui Calçada, full professor at the Civil Department of this faculty and director of the field. Thank you very much.
So, good afternoon. So, dear Secretary of State for Digitalization and Administrative Modernization, I was informed that he could not be present, but you sent a video that we will share with all participants. Dear José Manuel Mendoza, Emeritus Full Professor and Chairman of the Board of Inestec, and allow me in this person to greet all the members of the management structure, researchers and collaborators of Inestec. Dear invited speakers and moderators, dear distinguished guests, dear colleagues, dear participants. The Faculty of Engineering of the University of Porto welcomes all the participants in this open day of the Center for Telecommunications and Multimedia of Inestec. Inestec is an interface institution with public utility recognition that brings together academia, industry, public administration, society, seeking to apply knowledge and results generated in research and technology transfer projects, seeking to enhance the economic, social, and environmental value of science-based knowledge, contribute to a more cohesive, developed, and competitive region and country. I'd like to congratulate Inestec for organizing this open day and for choosing such a relevant and up-to-date topic, communication and machine perception, convergence and societal challenges, and many sectors could benefit from this, from transportation, health, manufacturing, energy, many sectors. Such applications are for sure an opportunity to ensure that digital technology will fully support the green transition, contribute to a fair and sustainable world. Allow me to thank and give a special congratulations to Professor Manuel Ricardo, full professor of FEUP, head of the Electrical and Computer Engineering Department, coordinator of the Center for Telecommunications and Multimedia of INESC, and also coordinator of this CTM Open Day. She should be working in 6G mode for all these activities, so I congratulate him, and in his person also to greet all the members of the team involved in the organization of this Open Day. I conclude by renewing my welcome to all participants in this Open Day, wishing it meets the objective of promote awareness and discussion of selected emergent research topics and allow all the participants to share their views and discuss the convergence of communications and machine perception from a technological viewpoint, also analyze the impact on societal challenges and environmental sustainability. I wish you have a very pleasant stay afternoon in the Faculty of Engineering, and thank you for your attention. So enjoy, please.
Thank you very much, Professor Rui Calçada. It is now my pleasure to invite Professor José Manuel Mendonça, Emeritus Professor of the University of Porto and President of INESC. So he will kick off the technical program of this event. So Professor José Manuel Mendonça, the floor is yours.
Dear Professor Rui Calçada, Dean of the School of Engineering, dear Professor Ivan Sisker, our keynote speaker today, dear Professor Olindo Oliveira, thank you very much for joining us and making the effort to be here today. Rui Campos, Manuel, Paula, Luís Pessoa, and all, I greet you all. It's a great pleasure and honor to be here opening the CTM Open Day 2023. I recall that there is an Open Day by the CTM since many years ago, and always discussing very important and strategic themes. And today it's not less important than the last years, because communications and machine perception, including computer vision, have evolved as two independent areas, and I can recall, although not being in the area. But with the advent of wireless communications operating in very high frequencies, these two areas are converging. They will converge. On one end, computer vision applications may become more robust through the help of distributed radio radar-based imaging. And on the other end, wireless communications may provide higher bit rates and be more reliable when helped by advanced sensing and computer perception capabilities. The combination of these two areas will be potentiated by a third one, machine learning, which will lead technology to a new, they say, perhaps revolutionary level. For instance, the future 6G telecommunications network will become an ubiquitous system capable of transferring instantaneously, between commas, hundreds of gigabits per second, and also mapping its environment with millimeter resolution while having a Superman-like vision capable of seeing beyond obstacles. I recall Superman was when I was 5 or 6 years old, and I wonder what would be the kryptonite of this Superman, but you will certainly know what will be. The number and diversity of applications that may emerge from this conversion field has yet to be defined, but it has an enormous potential economically and socially, and it will certainly affect economic fundamental sectors such as industry, energy, sea, health, and telecom. These applications will only be identified in collaboration with the leading companies in these economic sectors that should be partners in processes. But this convergence has also many challenges, like the new technology to be developed needs scientific tools yet to be characterized. The validation of this new technology demands new laboratory infrastructures in which radio, sensing, and video can be jointly studied and jointly investigated. And the entrepreneurial initiative should be aware of and use these facilities in order to inspire, prototype, and test new applications. INESC and the University of Porto the School of Engineering, specifically the Department of Electrical Computing Engineering, as you are as many times before, assuming the role in leading this innovation process. Inestek is leading the large European project Converge in cooperation with European and North American partners to develop novel scientific instrumentation for this convergence field. University of Porto, Faculty of Engineering, and Inestek are also creating relevant laboratories for testing the new technology that will be equipped with new scientific equipment and put to the service of the region and of the country for the development of impactful applications. Today, we will discuss the technological issues associated to this convergence field of communications and machine perception. We will speculate about new potential applications that may emerge and about its benefit for society and the environment. But we'll also discuss challenges such as intensive usage of artificial intelligence in a field like this. I would like to thank all speakers for their presence and contributions, particularly to Professor Sisker, that's coming from US to give his views and insights and participate in discussion, and also Professor Arlindo Oliveira, known and reputed expert in artificial intelligence, the third area, helping potentiating the conference, coming from Lisbon to moderate the panel. Thank you all to the organizers, and I wish you a very, very fruitful afternoon. Thank you.
Thank you very much, Professor Manuel Mendonça. So now that we have the event officially opened, we will see and hear a communication from Mário Campo Largo, the Secretary of State for Digitalization and Administrative Modernization. Although he could not be present, given the importance he places on the topics that we are going to discuss here, he did not want to fail to send his message of encouragement, motivation, but also of clarification on the strategy and public policies concerning the transition from 5G to 6G and the introduction of edge technologies to promote economic progress and social inclusion and well-being. So let's see the video.
Good morning, everyone. I begin by greeting and thanking Inestek, in particular Professor José Manuel Mendonça, for the kind invitation to participate in the CTM Open Day 2023. As a Secretary of State for Digitalization and Administrative Modernization, but also as an engineer, you can well imagine how the theme Communications and Machine Perception challenges me, both personally and institutionally. For Portugal to take full advantage of technology, enabling a secure, dynamic, data-agile economy, for Portugal to reinforce its image as a digital nation and be always more attractive, we need to deploy state-of-the-art connectivity and good communications. Certainly good communications between people to reinforce, for example, social cohesion, and more, communications between people and machines, machines and machines, to get higher degrees of, for example, economic efficiency. Well, Portugal is strongly investing in connectivity and communications. In the context of our national connectivity strategy, this year we will launch a public tender for very high-capacity networks in white areas. Our purpose is to ensure coverage of the entire national territory of Portugal and of all the households with gigabit networks by 2030. And we look with interest into the deployment of 5G. You should know that the 5G coverage of the population in Portugal is already higher than the European average, and that only 6 out of the country's 308 municipalities do not have a single 5G station. We are also investing in attracting submarine cables, giving Portugal a centrality in the digital world that may counter the geographical peripheric situation of Portugal in Europe. Well, talking about periphery, you focus today on edge technologies that will combine multiple sensoring capabilities and will greatly innovate in gathering and processing detailed contextual information and data in a semi or even fully autonomous way. that can be either treated on the periphery for real-time scenarios with edge computing for sure, or combined with other sources of information and data to allow for the monitoring and influencing, maybe controlling the physical world. Through policies determined by efficiency of economic organizations, if we are talking in the context of Industry 4.0, or by the social interest of the community, like when we are possessing intelligent territories. In other ways, and in large sense, you focus today on the next wave of IoT, computer and communications, but also on the emerging applications of disruptive technologies that exploit the exponential power of data. So today, it's my pleasure to salute the leadership of INESC in a project such as Converge and reaffirm that the Portuguese government wants to create the right environment for projects like this to flourish and impact directly in our social and economic fabric. That's why we created technological free zones, regulatory sandbox where companies can test innovative products, services, or business models without specific regulatory constraints, but in co-creation processes with the competent regulatory authorities. That's also why we created and we fund test beds, catering for the testing and experimentation of novel products and services in fairly advanced infrastructures. That's why we support also digital innovation hubs, spaces aimed at creating widespread competencies on IoT, artificial intelligence, blockchain, and cloud computing, and cybersecurity. And that's why we are currently developing or adapting the national strategies on data, Web 3.0, artificial intelligence, and elaborating its respective action plans. Dear friends, these public policies and others more focused on research, science, and technology are designed to foster the research and application of cutting-edge technologies. And I must confess, if you allow me, that I'm fascinated by the prospects of computer vision and machine perception. But those policies are also designed to encourage innovation while protecting citizen rights, establishing clear ethical standards, ensuring a fair and equitable transition to new ways of manufacturing and working, and promoting digital inclusion. Ladies and gentlemen, to maintain Portugal in the front row of digitalization, to be a digital nation enabled by an ecosystem of science and innovation, we count on your work and your own creativity. We want to be your trusted partner in this successful journey. Have a nice event. Thank you very much.
What a great message, so motivating and as well very informative. So it's really great to hear that what we are here discussing is so important for our country. Okay, so now it is my pleasure to introduce our distinguished keynote speaker, Ivan Sheska, from the School of Engineering, Rush University in the US. Ivan is a prominent expert in mobile communications and is currently chief technologist at WinLab, as well as responsible for Cosmos, New York City's 6G experimental testbed, focusing on building secure and inclusive communities supported by hyperlocal technologies. So let's give a warm welcome to Professor Ivan Sheska.
Thank you very much. Thanks a lot. Okay, so I'm not sure, can I move? Can I move? I can move. Okay, that's good. Because I tend to walk when I'm talking. So I have infinite number of slides, and I first have to start by saying that a lot of material in these slides is actually done by a lot of people, a lot of multi-institutional collaborations, and I'll be talking about stuff that I not necessarily know much about. So I'm not, disclaimer, I'm a wireless guy. I don't know much about multimedia stuff, image processing. There will be a lot of that in the talk. So, you know, if I can't answer the question, I will make sure to find a person who will be able to do it. So just please reach out offline and I can make sure that you get the answers to all the questions you might have. Okay, so let me start first by sort of talking about the Cosmos testbed, right? And so the whole idea of Cosmos testbed is really talking about next generation of wireless communications, which are based on edge computing and presence of high-performance communications, right? And so the focus of testbed was to sort of, and remember, this started in 2018, So the focus was really on developing a platform where people can try things out, right? And therefore, the programmability and extensibility was actually the crucial design element of the testbed. I mean, these are all the things that we know about. The whole idea is to sort of look at ultra-high bandwidth, ultra-low latency, even though I have a beef with people talking about low latency and multimedia communications, and of course, edge computing, right? So think of it as sort of creating a platform in the highly dense urban environment to sort of play with these things, right? That was the objective. Now, I'm sort of really curious to hear, maybe later in the panel we can talk about it, what people consider a low latency and why do we need it? And I'm still looking for that magic sub-millisecond application that everybody is talking about. So leave the questions about that for the panel, and I'll gladly entertain it. So I added this slide. This is the Orbit testbed. This was built in 2004, right, and opened to public for 2005. It still functions. It still works. Everybody is more than welcome to play with it. But the point is that this is an environment inside a big, large room with a lot of programmable nodes hanging off of the ceiling, and people can do experiments. We literally give you all this hardware to do stuff. And so in 2016, White House sort of said, okay, fine, we have to experiment with these new forms of communications. Can you guys come up with the test beds that are deployed in real world as opposed to fully controlled environment like this? And sort of the idea was, okay, let's try to deploy this in West Harlem in New York City, which is one of the densest possible places to deploy anything. And you can actually see here, this is Broadway, and the subway actually comes out of this underground on the surface, and then goes back under. You can see it at the end of the tunnel. So this is picture taken from 120th Street, looks up. You can see the George Washington Bridge going to New Jersey on the top left-hand side of the thing. And this is our testbed deployment area. Now, when we sort of talk about technologies, and remember, this is 2018 when we started the deployment, right? The focus is on high-speed, high-performance networking, wireless networking. Therefore, we had to move on to millimeter wave stuff, right? Assumption was that that's the high-performance target deployment bands. We do support sub-6 gigahertz. The point is that behind all these front-end technologies is software-defined radios and software-defined networking. And of course, another crucial part of the whole thing is the fiber, because you need massive amounts of wired networking, in this case fiber, to support things like edge computing, core computing, or combinations of both. And then ultimately, we have a lot of different heterogeneous processing technologies throughout the testbed, meaning all three forms, GPU, FPGA, and CPU, as well as some TPUs more recently introduced into the platform, right? Now, looking at the deployment, this is if you look at Manhattan, right? The deployment area is, as I said, in the upper left corner, West Harlem, sorry. And then we have fiber going down to what's called the 32A of A, which is the largest carrier hotel on the East Coast. Carrier hotel meaning that all the networking from around the world actually comes into that same place. You have 32 floors of building with 32 floors full of communication and computing equipment. And then, of course, from there we go all over the world with connectivity. The deployment phase, you can actually see the ambitious plans there. The small squares sort of point out where we deploy what we call the medium nodes. Medium node for us is something that you put on the lamppost or side of the building. The large node is something that lives on the floor, on the roof of the building. It's multi-sector type of deployment. And then we have what we jokingly call near portable nodes. As you can imagine, software-defined radios and programmable equipment is not something you can easily put in your pocket, so you need two hands to carry these things around, right? But nevertheless, we have experimental devices that are capable of doing high-end processing in semi-portable way. So this is the timeline. As you know, COVID destroyed all the plans and all the timelines. For 2 years, we were not allowed to do anything in the city, so we had to sort of postpone things. Interesting point in time is the September of 2020 when the whole testbed was declared as FCC Innovation Zone, and you will see in the next slide why. And then, of course, going towards where we are now, we are just finishing what we were hoping we were finishing early 2020, right? Which is the phase 1 deployment. And these phases are literally just a number of nodes that we are deploying. Now, why is FCC Innovation Zone interesting? So look at what FCC did for us. They declared the whole testbed area, which is that red coverage area, as a place where you can play with all these things, right? And if you look at it, there is some of the prime spectrum that's available for us to play with. Now, when I say we can play with it, it doesn't necessarily mean that we can just go and start transmitting, right? We still have to go on the website and register an experiment and sort of say, you know, next Tuesday from 9 to 5, we are going to emit in 28 gigahertz. And if Verizon or AT&T or whoever is the owner, primary owner of the spectrum, has a problem with that, they can actually kill our experiment, right? They can come back and say, no, 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 you are not going to do that. But nevertheless, we have a very streamlined procedure to play with these frequencies. We also have what's called the Program Experimental License, which is something that all land-granted universities in the US have, where you can go through the similar process, but it takes a couple of weeks to get permission to do similar things. So in other words, on all universities, and by the way, Cosmos testbed sits between Columbia University and City College, meaning Columbia University is from 116th to 120th Street, and City College is on 135th to 240th Street. And you know, that sort of, again, gives us permissions to do some other stuff. Now, in addition to deploying things on the high-dense environments, we have a number of sandboxes, what we call the sandboxes, which are sort of enclosed environment that you use for development. And one of them is the, we jokingly call it Industry 4.0 type of thing, right? But it's actually industrial environment in one of the labs that is equipped with the fully programmable devices, and people do all sorts of stuff. And again, I know nothing about how milling machines work, so please don't ask me questions about that. I can tell you how testbed is used in this context. But it's actually probably one of the very few places where we see real need for very low latency, right? Because the robots are talking to each other and doing stuff, and things are happening at high rotational speeds, and maybe that is argument for doing very, very low latency stuff. Now, one of the big mandates that all the National Science Foundation projects have is what's called the outreach, right? And we do a lot of stuff. The most interesting aspect of the outreach, in addition for us building a small kit that we give to schools to play with, in other words, think of it as small-scale testbed that we allow each student, or not student, but school to get so that they can do experiments in their own local environment before they come to the large testbed to do stuff, is the fact that we have this program called Research Experience for Teachers, where we bring teachers from middle schools and high schools, which means grades 6 through 12, to develop curriculum for STEM education, right? And they did an amazing job. I was really sort of skeptical that they will be able to do, you know, what can a sixth grade student know about wireless communications, right? It's highly unlikely that they know much. These teachers developed amazing curriculum. It's all available online, and you know, we actually, in the meantime, because we cannot manufacture enough of these toolkits to give to everybody who asks for it, we sort of created the online version of it so people can at least do some subset of experiments, even if they don't have this hardware that we give to teachers, right? And we are doing this now again, this year again, and we, you know, the last 2 years it was virtual, but you know, this year again we'll have people in place to do things live. So just to summarize this slide, I mean, I'll make sure slides, you get a copy, a PDF of the slides so that people can go, because I'm sure I'm going to run out of time, so towards the end I was just skipping slides. But this is the conclusion. So, you know, the whole thing is readily available, and people are doing experiments now for 4 years on the testbed. And just as an advertisement, everybody, you guys can also do experiments. Nobody needs to sit in New York City to do an experiment. It's all available remotely. Of course, if you want to do some crazy stuff with portable equipment, you have to be in the city. But, you know, let's say sensing or monitoring experiments can easily be done without anybody coming in. Now, cosmic, right? So this is relevant in the sense that in 2020, National Science Foundation sort of said, hey guys, can you expand this and connect multiple testbeds? We wrote the proposal, and COSMIC stands for Cosmos Interconnecting Continents. So you can actually see the participation from Europe and Japan and Brazil, right? And the idea there is, of course, to sort of come up with the experiments that span continents. And it's not just for doing some crazy experiments, and it's really hard to come up with a wireless experiment that you do something in Dublin and something in Tokyo at the same time. It's highly unlikely that anybody can bridge that distance. But there is a lot of interest in sort of different capabilities in different test beds, which this now federation enables us to do. And we are also, of course, part of, as you know, part of Converge. So the hope is that we will be able to do stuff collaboratively with other test beds, including the ones here, right? And of course, the slices, we are participating in slices as well. So hope is that, if nothing else, at least we'll be able to share data on all sorts of things that we are doing that are of similar interest. Now, fast forward to last year, given the success of the Cosmos experimentation that people were doing, especially during the COVID years, we sort of decided to participate in something that's fairly large in the US. It's the so-called ERC. It stands for National Science Foundation sponsored research center, right? So it's sort of multi-year, up to 10 years funding with $25 million of funding focused on particular multidisciplinary research. And if you really, I mean, it's amazing. It's almost identical to what Converge is all about, right? So that's what Streetscapes is dealing with. And as the title implies, you're looking at smart street spaces in the highly dense urban environments. Now, I don't have time to go through all of this, but you can see who are the main players. Columbia is lead. Rutgers is lead for Cosmos, and Columbia is lead for ERC, right? And then you have, of course, number of other institutions participating as well. Now, if you look at what's the idea, right? The idea is to sort of do the high precision, real-time understanding or situational awareness in highly dense urban environments, right? And this includes all sorts of aspects to it, right? And then, of course, we heard it already a couple of times before my talk, the community-defined benefits. That's something that community has to participate in. So the idea is to sort of create this inclusive environment where we do both experimentation, development, testing, and get continuous feedback from the community. In other words, develop stuff that community cares about. Now, if you look at, I wanted to talk about the main development areas, right? So safety and traffic efficiency is one of the objectives of the setup, of the research. The assistive technologies, that's actually something that we came up with. Can we come up with an urban environment in which technology is going to help people with disabilities? And you can argue what kind of help is needed, but the idea is to develop assistive technologies where both the infrastructure participates in helping. So the best example is like if a blind person is crossing the street and you can identify that, can you stop the traffic lights from changing before that person crosses the street? Now, of course, there are all sorts of, people who do multimedia immediately realize, how do you know somebody's blind? Right? So is there a way to do these things without having to label people up front? And there are all sorts of issues that we can talk about, but the idea is fairly noble. The main issue is let's talk to people with disabilities and let them tell us how they see this and what is the important way to help them. Right? And then, of course, you have other issues which every urban environment deals with, which is public works. You guys, there is a lot of digging going on around Porto, right? So how do you help with that? In New York City, the biggest issue is trucks that are double parked when people are offloading material into the stores and stuff like that. That creates massive problem in New York City. So can you help with that? Can you suggest sort of incentives or pricing incentives for people to come at 3 in the morning to offload those trucks as opposed to 10 o'clock in the morning, right? Because they create massive problems. So anyway, a lot of interesting things, and we have these sort of layered research areas where you, at the bottom, you have sort of, as you can see, electrical and network engineering really is just one small sliver of the issues that one has to deal with in these smart streetscapes, right? And then going all the way up to the development of applications on the very top that we will have to come up with to create things. And I will try to illustrate, so these are just the descriptions of the testbed. Actually, as opposed to just Cosmos, there are 3 testbeds that are involved. And I'll talk about 2 of them I have some input to. So if you look at, this is the Cosmos deployment area, and then you can now see where the ERC headquarters, the CS3 ERC headquarters are. And you can actually see how we want to expand further and to create these 3 corridors, which are shown here in orange, meaning the Amsterdam Avenue, the Broadway, and the 125th Street, which are the main arteries in the West Harlem, to sort of try to somehow create a situational awareness for this region. And it's not easy. I mean, there are a lot of things that need to be covered in order for this to happen. Now, talking about testbeds, right? So we have a testbed in Florida that's participating in Cosmos, and this is a very nice pedestrian area where they have a lot of these small nodes and they're monitoring Wi-Fi traffic and trying to sort of look at what can that tell us about what's happening in this pedestrian area, right? Then, as you can see, the plan is to actually deploy some Cosmos nodes as well to sort of create a more experimentally friendly environment. But nevertheless, the point is that this is a pedestrian area and very specific urban environment that's sort of interesting to look into. How do you hyper precision monitoring in there? The other one that's sort of interesting is in New Brunswick, and actually Rutgers University is headquartered in New Brunswick. So there is a highway that's sort of flowing around the river, you can see it, where the New Jersey Department of Transportation deployed high-resolution LiDARs, cameras, and stuff along the segment of highway, and we were lucky to actually get access to that. So we have all these data sources that you can actually see listed here. I think deployment is really pretty much over, meaning that the whole length of the highway is now fully equipped with these high-resolution sources of data. Now, privacy aside, hopefully some of this data will become publicly available shortly, right? And then, of course, given that this is one of the flagship projects, you can actually see the industrial environment around the whole testbed. In other words, this is not just a research initiative. There are a lot of people who have interest in sort of playing with this stuff. It's not clear that they will all be able to play with it, but this is actually the target community that lives around the smart streetscapes infrastructure and people who are interested in playing with it. Okay, so let me now do, and I'm already running out of time, I'm sure. So let me go through the research topics that actually came up both before and during the CS3 deployment and Cosmos, right? So the first one is the millimeter wave stuff, right? So we did a lot of work in the last 5 years on millimeter wave, massive amounts of measurement, right? And you will see why we need them. So there are some references here so people can see a little bit more technical details. All I want to say is that sort of these are the examples of narrowband measurements that we did together with Bell Labs, Nokia Bell Labs, right? And as you can see, we collected 41 million measurements in the last couple of years, right? Just based on sort of positioning these narrowband channel sounders on the various locations in the testbed footprint, right? And some of these data sets are publicly available, some are not. Now, talking about that, you can actually see literally along the 120th Street and along Amsterdam Avenue, our ability to sort of characterize the environment really fairly precisely, right? And you will see why that is important. Now, we did the same thing for indoor and outdoor locations, right? And then something that's my pet peeve project, not just at millimeter wave, but also in this newly available band from 6 to 7 gigahertz, is this notion of nonlinearity when we transition from indoor to outdoor and vice versa, right? And this is something that we really don't necessarily fully understand. And I'm not sure if you know about 6 to 7 gigahertz. The idea there is that it's allowed for indoor use in the US, but not for outdoor use, because they are already primary owners of that spectrum. The big problem is that, how do you know that you went from indoor to outdoor? I mean, we don't have propagation model that shows that. So it's a very interesting way to sort of think about how we do propagation modeling, and you saw that we did for millimeter wave the single slope model, and you look at sort of trying to run through the data. It actually gets way more complicated when you have that stuff. So in order to sort of look at that, we created a number of measurements sort of radiating millimeter wave from the outside to the inside, and the idea is, can you support, say, schools and other institutions where you have a large number of people indoor by outdoor deployment of millimeter wave stuff? And by the way, there is a big sort of, at least in some circles, doubt that millimeter wave will ever work properly for support of 5G, right? So people are sort of now pushing with 6G to even higher frequencies, so I'm not sure where are we going as a community. We should really finalize the answer for millimeter wave, whether it's worth it or not for mobile communications. But that's just my personal opinion. Now, channel sounding, so this is actually, and Edward is not here, but this is actually using the software coming out of Rice University. They have a really nice package for software-defined radio-based channel sounder. And you know, we sort of extended it to support millimeter wave stuff. And again, the idea is how do you sort of characterize the environment using wideband waveforms, right? And this is actually readily available as sort of for anybody who has USRPs and millimeter wave equipment. The other example is what we call the bring your own device, right? So we allow people to bring their devices. In this case, Columbia University Flexon Lab developed the full duplex setup. So we now have that setup both in orbit and in Cosmos deployed permanently, and people can do experiments, right? And they were nice enough to leave some of these full duplex devices in as a permanent deployment in the testbed. Now, industry uses quite a lot of this concept of bring your own device, where we let them bring the equipment in the testbed, do the experiment, and then take it away. And we are hoping that some of that equipment will, what we jokingly say, fall off the truck and stay in the testbed for everybody to use. But it's happening, but not as many times as we would like it to happen. Now, another example is really using these metamaterials, where we sort of try to use, call it smart surfaces or smart antennas, to sort of mitigate some of the impacts that interference might cause. And you can actually see how you can sort of do directional communication really well with these metamaterials, right? And that's actually a big sign of research. This is just a slide to flash the rule of use of machine learning in the physical layer research, and we do a lot of that stuff. I'm not going to go through all these things because there are way too many of them in there. Now, one thing that happened, and this is sort of part of the recently pushed notion of research needed for what's called the National Radio Dynamic Zones. So in the US, you have a lot of spectrum that's available for very specific uses. Weather sensing, satellite sensing, astronomy, and stuff like that. And so the idea is to sort of try to find out ways to use that spectrum for communications as well. Now, of course, that means that you have to coordinate in some way with primary owner of the spectrum. And quite often, that primary owner is what we call the passive spectrum. So your sensing is not going to help you there, right? Because you don't see the radio astronomy receiving antennas, these massive arrays that they have all over the place, right? You don't see them emitting anything. So, you know, if you just sense, you will assume that the spectrum is available, which of course it's not. And actually, one of the best examples is if you can come up with a coordination technique, that would be great. And one of the coordination techniques that we are pushing forward is, and actually this zone management system is something that NTIA and FCC are pushing for, meaning some entity that's going to manage the spectrum use in the area, right? And so one thing that we are pushing for is sort of this notion of using what's called the spectrum consumption model, meaning the ability of devices to declare what they're doing and your understanding of what the environment is, to sort of try to figure out in advance what is going to be the interference if you try to communicate. And then, based on worst case interference, decide whether it's okay or not to do things, right? And if you don't know, IEEE actually has and I'm just keeping sites, right? So in this particular case, we have within the spectrum, within the Cosmos zone, we have a national NOAA sites. NOAA is the National Oceanic Atmospheric Administration, guys who are monitoring weather. And they have a 24 gigahertz radiometers at the roof of the same building where we have our Cosmos deployment, which means that we have a device which is, you guys think 4 gigahertz, 24 to 28 is big enough not to interfere. It turns out it's not, and you will see the slide, right? And so the idea is to sort of do this fancy calculation of interference and figure out when and how you can emit without causing problems for these monitoring sites. And actually, here is the physical distances that we are talking about. And you can actually see the large Cosmos node is in this corner, and the NOAA satellite receiver and radiometer looking up is like 100 meters away, which is pretty much enough to cause interference, right? And that's actually one of our objectives, is to measure stuff. I'm not going to talk about SCMs that much, just to say that there is IEEE standard. It's very interesting. If you look at what it allows you to do, it sort of allows you to exchange all sorts of information between multiple systems, right? And then, of course, do the calculation and figure out what's the worst case interference you're going to cause, assuming that you know where everybody is, right? So in other words, you need to characterize the environment, which actually brings us back to that 28 gigahertz testing that we did and characterization of the environment that we did earlier. So that was actually the main contributor to us being able to come up with these SCM models for 28 gigahertz. And now we want to repeat the same thing for 6 to 7 gigahertz and see what's going to be the result. And I mean, there is a paper, distributed algorithms, how do you figure out, is it centralized or distributed? How do you figure out who's interfering with who? And then, of course, the biggest issue is who will be the arbitrator to sort of say, yes, it's okay or not. And this is where now FCC and NTIA, FCC is the civilian and NTIA is government agencies, they have to tell us it's okay to arbitrate or not. So now, I was talking about the weather radars, right? So the band, the leakage from N258, that's FR2 band in millimeter wave, is non-trivial. All I have to do is show you this slide, right? So look what happens if you take the tornado data set. And remember, tornado is a deadly thing, so you want to pretty much make sure that you tell people tornado is coming, get into a shelter, right? Interference from the 28 gigahertz 5G system is enough to cause 1.3 centigrade difference in estimation of the temperature, which is crucial for their, I mean, I don't know, again, I know nothing about how you estimate where the tornado is going to go, but it's apparently enough to throw them off completely, which means, of course, that if you have, and remember, these are mobile radars that they deploy when there is a tornado in the area. So what happens if that starts interfering with the deployed 5G network? If you're using FR2, that becomes an issue, right? And so that's something that we have to work on as a communications guys to sort of come up with the solution. And you have similar impact with the low Earth orbiting satellites, including Starlink. So they're talking about people who are monitoring the skies, and maybe radio astronomy is not that critical. It's not nobody's gonna die if they can't observe the sky for a few minutes, but they will lose a lot of money and a lot of things if that lasts much longer than what their observation is. And remember, those guys are using cryo-cooled sensors, which are way more sensitive than anything we deal with, right? So if you talk to astronomers, they say, oh, we can tolerate interference of minus 150 dBm. I mean, I don't know how to measure minus 150 dBm. Okay? We don't have instrument that can measure that. I mean, I'm sure they exist, we just don't have it. Okay? So now, moving forward, optical networking, as I said, that's one of the big things, right? So the idea is to sort of look at how do you collect massively data coming from multiple sensors and push that into a system that can quickly switch where things go. Assumption is that you can do that through the optical layer. And as I said, Cosmos has a massive optical switch in the core of the deployment, a lot of spools of fiber to emulate different topologies, and ability to create topologies where you look at how these things behave. Meaning you can switch lambdas and do all sorts of processing in different points to sort of create situational awareness. This is one of the examples. It's way too busy a graph. All I have to say is that, this is the NEC looked at their 400 gigabits per second synchronous optical system and sort of try to show that you can coexist with radio or fiber stuff that's typically very sloppy in terms of using a fiber, and then some traditional optical communication things, and be able to switch things dynamically and move things around. And of course, the 400 gigabits per second synchronous traffic is a tricky thing to deal with, right? And the idea is to sort of show that this is functional. NEC brought in their equipment, did the experiment using our dark fiber that we have in the footprint, made the measurements, collected, and unfortunately took the equipment away. So now we're trying to get them to bring it back and leave it with us, the 400 gigabits per second stuff, right? It's quite interesting. Edge cloud. So now I'm going through the projects. I try to put attribution to people who you can talk to about these things. Centralized edge cloud versus distributed edge cloud. This is now a big discussion in the US, whether, say, a mobile device moving across multiple networks can actually use different providers of the cloud, of the edge cloud, right? And the question is, if you can, how you do that, meaning how do your payload and your computing moves laterally? Because this is now not the same provider. And that creates all sorts of interesting issues, up to a point where we are even talking about, because there is this thing called Xfinity, which is the cable service provider, and they have a very interesting ability. They give you a wireless access point, but then you take, you have to allow other people who have Xfinity to use your access point if they come in the vicinity. So now you can argue, okay, if you have a computing in the house as well, why not allow people to use your computing as an edge computing if you need it, right? So that's a little bit far-fetched, but that's the basic idea, right? In the lateral moving. National Mobile Edge Sensing Testbed and Computing Testbed, the idea is that we have a lot of cellular phones. They're all over the place. Different providers. Can you come up with the APIs and means of sort of unifying how computing loads are executed? And if you can do that, then you will suddenly end up with a platform that can do an unbelievable sensing across a fairly large number of devices, right? The question is whether that can be done. Now, the AR, VR. So interesting thing is that modern AR and VR headsets don't have computational capabilities, or at least not as much as we want them to have. Think about Oculus 2, right? It's really a display. I mean, fancy remote display. So you have to do all sorts of computing in the back end. The question is, communication then becomes a bottleneck because you need massive amounts of data to do immersive video across the wireless link. The idea is to sort of look at these notions of, okay, what is person really looking at? And if you ever tried it, just do it at home, take a book, put your finger in front. You're focusing only about the size of your thumb. Everything else is going to be blurred. So your vision is really only reading this much. And of course you scan, that's how you read. But your focus is really very narrow field of view, right? And so therefore, we can send only that part, right? If we can figure out where you're looking, we can only send that part really sharp and then blur everything else, and you will be completely ignorant of that happening. So that's one of the things, and of course the question is how you do that. Now, this is an example of the project we did together with a number of European partners under the NGA Atlantic, which is one of those calls where you can apply for open call and get some funding to do it. The idea was to do the spatial computing, right? So you try to describe the space and then use your phone to sort of look at some embedded things in the physical space, right? In other words, AR built on top of the phone, but with open source platform. And so we did both indoor and outdoor environments. So you see here the lab, and then you see the outdoor, we did it in the Cosmos testbed. And there are now a number of these initiatives going on. OpenAR is one of the bigger ones in the open source community. There are a lot of closed source things. We were discussing that before lunch, right? I mean, it's very interesting. What you can do is overlay commercials that when you go to, say, Times Square, right? You have those giant TV screens that are sort of all the buildings that you don't see the building, you see the screen, right? All over the place. And they're showing various commercials. I can easily override those commercials with my own stuff, right? And if you look at through the phone, looking at that, you will see something completely different than what's there, right? So now immediately lawyers are jumping in and saying, no, you can't do that. This is killing all the revenue coming in from these guys. But anyway, ours is to develop it. Lawyers will figure out how that can be used. So just to illustrate what you can do, right, with this thing is we develop the applications and everything else. And so here you see the sort of these funny objects, the rubber ducky and the turtle floating in the orbit room, right? If you look at through the camera, through our application in the orbit room, you see them floating, right? And you can retrieve or put additional content in it. And of course, the idea is not to put the rubber ducky and the turtle in there, but to sort of do something useful. And in this particular case, we have an application where you can overlay, say, different visual information on top of the testbed to see what's going on, right? Even though physically you don't see it. Going on, and I'm running out of time. So the idea is to sort of look at how do you do machine learning, how do you simplify machine learning so you can do them on a constrained devices. In this case, assumption is that sooner or later phones will have some capabilities to do machine learning implementations on them, including targeted engines. So the idea is to sort of look at these different compression models and try to sort of reduce the requirements so that you can do immersive distributed machine learning on edge devices, right? Real-time distributed ML, we heard it already, right? So there is a big project right now to sort of look at this notion of real-time distributed ML, where you're moving through the space, and as you're moving, your machine learning application is being both distributed and moving with you. And right, think in terms of long-distance driving and stuff like that. Okay, so finally, smart intersection stuff. And this is actually what caused sort of, I don't want to say misuse of the Cosmos testbed, but all our medium nodes have cameras attached to them, high-resolution cameras. And very quickly, people sort of decided all that wireless stuff is irrelevant. We want to do smart cities type of things. And who am I to say that's not allowed, right? I mean, testbed is testbed, research is research, so it's perfectly fine. And so you can actually see the sort of this notion of, okay, we need something that's real time, and you can see the attempt. Actually, I have a much better video coming next. One thing that we always wanted to do is self-driving, and there is absolutely no way anybody will allow us to do anything in New York City that's related to self-driving, right? So what we ended up doing is we built that top right-hand corner. We built the little intersection, model intersection of 120th Street and Broadway, and we are using 1 to 15 scale models of cars and streets, and the complaint is that our streets in the model are too nice compared to potholed New York City streets. But other than that, you can actually see how it looks like. I mean, you can drive these model cars. The catch is that you have to be there because we need to charge the cars and all that stuff, so we don't do remote support for those. Whoever wants to play with this model intersection has to actually come in. Now, the ultimate goal is this, right? So we call this a radar map. So looking at the analysis of what's going on in the intersection, right, you try to come up with sort of these trajectories that each participant in the smart intersection is doing, and you can actually see the correlation between the video and the radar, right? It's sort of you're labeling all the objects you're trying to figure out, and of course, our next step is to try to do prediction, right? Meaning, are the pedestrian and the truck going to intersect? If they are, that's not good, right? In most cases. So anyway, that's where Smart Streetscape came about, right? The Research Trust 2 in the Smart Streetscapes is sort of focusing on these major elements, right? I will go quickly through some of those. So the digital twin, so we are building a digital twin of the whole setup, right? And the idea is to sort of look at the prediction and control. Now, control is still not clear, right? One obvious element of control is the traffic light. You can play with that. But other stuff, I mean, how do you stop a pedestrian from crossing the street, right? To put something physical, or I don't know, right? One of the ideas was to sort of broadcast these messages and sort of say, hey, you're about to be hit by a truck. Again, you can see that there is a lot of issues. How do you actuate? Meaning, how do you feedback what you're learning about the situational awareness? And that's actually quite an interesting thing. How do you deal with this feedback of physical world, right? Just to illustrate how this really works, anonymization, right? So this is, again, one of the NJ Atlantic projects which we collaborated with the European small company in, can't tell you, I don't even know, I think they're somewhere in France, right? The idea is to sort of look at this notion of, okay, I have a raw video, I process it, and then I sort of track all the elements, you saw that, but then I need to sort of send anonymized data to this application. In this particular case, they're just looking at collecting historical values of what's going on in the intersection so that they can do some fancy prediction on top of it, right? And of course, we feed that data back to them, and this is how it looks. Sure why animation is not starting, right? So they can actually get historical data about all these things that we detect in the intersection, right? Now, everything is anonymized, and apparently that's enough for them to do some management of traffic. And I'm not a civil engineer, so I don't know anything about traffic management, but apparently that's what these smart street traffic lights do and work on, right? Next thing is sort of the anomaly detection, right? So that's something that we are all interested in. And just to give you an example, traffic accidents, right? Self-driving cars. They have to run, I'm not sure, maybe it's a wrong number, but I think 50 million miles to get to an event that's of interest now, right? Meaning a crash or something that they can use to learn what to do. And it's really a hard problem. So these anomalies are really essentially now getting to a point where we desperately need to get as many of those as we can so that we can train the models and learn what to do, right? And so just to give you, this should play. Yes, it's playing. So this is what they actually get, right? So think in terms of the yellow squares. This is fully anonymized. Yellow squares are pedestrians. Red is something we don't know. Green is the car. So you can see, if you just carefully look, I'll try to play it again. If you carefully look, there is something weird. There are people walking in the middle of the street, right? That doesn't, I mean, yellow squares, we don't know who they are. And so we didn't realize what it is until we observed this. Somebody was able to actually see it. We didn't get it, right? So somebody saw it and they're like, okay, what's going on? Let's go back to the video to see what's happening. This doesn't make any sense, right? This is what was happening, right? So this is not something that you know about. There is no way you can train your machine learning for something like this, right? And of course, those yellow squares moving into the middle of the street were workers who were going in and out of the work area, right? And so anomaly detection is one of the big things that we are looking into, right? And that's one of the thrusts too. Now, another thing is, as I said, we would love to be self-driving or assistive driving. Yeah, I don't think we want to put a student in the car and tell them go drive in New York City, right? There are some liability issues for that if you do research, especially the one that can distract you, right? So what we did is we created this simulation environment where we put the students into really sort of immersive thing, and we look what they're doing. And we try to give them feedback continuously, both from the infrastructure and from their own driving, right? So you're sort of saying, hey, you're not looking in the right direction because we have eye tracking, right? You're looking in the wrong way and there is a car coming that's going to hit you, right? That kind of stuff. So it's quite interesting, again, to sort of look at, and I'm horrible. I tried this a couple of times. I crashed every single time, okay? Because I'm obviously distracted with these multiple screens. I'm looking at graphics and not thinking about driving and all that stuff, right? So anyway, just it. And so if you look at sort of the Research Trust 5 in Smart Streetscapes, it's sort of trying to build applications on top of all the other 4 trusts that we have, right? And I promise this is the last thing, and I'll just skip quickly through it. As I said, the industry is big time interested. There is a big initiative in the US, and not just in the US, everywhere, to do the OTIC, or ORAN Alliance, which ORAN stands for Open Radio Access Networks, right? And the idea is to sort of come up with this open source implementation of telecommunication networks. I'm not sure that will ever really truly happen because big guys, as you can imagine, Ericsson's, Nokia's, Huawei's, and Samsung's of this world are not really big enthusiasts as far as open source stuff is concerned. But nevertheless, there is this big initiative, and then OTIC stands for Open Test and Integration Center. And then the industry in the US came up to us and said, hey guys, you're a sort of Switzerland of testbeds, meaning we don't have alliance to anybody, right? Can you become an OTIC? And I'm not a big fan of being an OTIC because that involves certification, and my role in life is not to certify devices. I don't, I mean, somebody doing that for money is okay, but, not me. But there is another aspect to it which is really cool, and that's called the proof of concept. So, you get all this crazy programmable equipment, and you can start playing with it, right? And that's what everybody is doing with these RICs, and whether it's R apps and X apps, right? So it's kind of cool. You can build your own sort of flavor of network management and radio management if you have something like this. So anyway, we became an OTIC. We've been doing this for quite a long time. We have a permanent setup that involves a lot of equipment that's sitting in the lab. So every 6 months, and actually one is happening literally, started yesterday, the so-called Plug Fest, where vendors bring their own equipment, they connect it to the test bed, and we do evaluation and performance management. And so this is just sort of showing stuff. Now, as part of this Open RAN Alliance, there is the next generation push, right? And NRGN is really the sort of this idea that they want academia to get more involved in this whole thing, right? And to sort of, because right now it's really heavily vendor dominated. And so here you see sort of the idea of what they really want to do. And we are members of the Oran Alliance, so we are participating in all of this. Okay? There is a slide on what we are in particular doing related to this, and for those of you who maybe don't know, open source intelligent network management and optimization. So the idea is to sort of come up with a control entity, the so-called SMO. SMO stands for Service Management and Orchestration, to sort of manage the network and do something cool with it that was hard to do before. And in this particular case, we are sort of working on the spectrum management where you have multiple private deployments of 5G. How do you coordinate them and make sure they work? And this is it. I'm sorry, I went way too long, but you know, you can find more. Most of the stuff, not most, all of the stuff we do is open source. So everything we do is available somewhere. And feel free to actually, both testbed, both Orbit and Cosmos are publicly available, as I said. So every one of you can actually run an experiment on those. So that's it. Thank you.
Thank you so much,
Sure,
Professor Shevka. It was really
Sure.
an impressive presentation of the tremendous work that you are coordinating. I'm sure that many of you would like to engage in discussions with Professor Seska. For the time being, we have just a couple
Yes.
of minutes, but later on there will be more opportunities. So if we have time for a couple of questions, so feel free to.
And I'm available. I mean, just send me an email. I mean, it's if you have any questions you want to ask in public.
Working?
Yep.
Okay. Thank you very much for your presentation. It was quite inspiring. Your test beds are really fantastic, so you'd like very much to do something that could be similar to what you have in New York. My question is following. What are challenges of installing and maintaining such a test bed?
I don't think we have enough time for me to go over the litany of problems we have. I think one thing that sort of, the biggest issue is that you don't really control the environment, right? So to give you an example, we still have a problem with one of our nodes where the manhole where we are supposed to thread the fiber through, nobody can find. It exists, but nobody knows where it is. And chances are, when they were doing some renovation of the building or something, they actually covered it with asphalt or something. So you can't, and you know, you are on the timeline to deliver, suddenly you can't find the manhole, right? And there is no way, I mean, you can't pull the fiber through because nobody can find the other end, right? So that's the biggest example of sort of real problems with the urban environments. The second one is, of course, policy. Policy is still a big issue, and a lot of stuff that you saw has a policy implication that we don't have a solution for. So, for instance, and we talked about this, legally, you don't have expectation of privacy in public spaces, right? In other words, if I go into Porto downtown and photograph something, chances are I'll get the number of people in that photograph. So therefore, they can't come to me and say, oh, no, you can't take a picture of me. I'm photographing something, right? I'm not photographing you. It just happens that you're here. If you don't want to be in here, move away, right? I mean, that's the rule of public spaces. We are not allowed, even though the same thing applies. You saw the 120th corner of 120th in Amsterdam. We are not allowed to share these videos with you, right? We have to blur the faces. We have to blur the license plates, even though it's a public space. So there are infinite number of examples. Like my biggest fear is you can monitor the spectrum in New York City, right? Which means you can literally record IQ space signals, right? What happens in 5 years when I'm able to decrypt the traffic, right? Right now, maybe encryption is good enough. We can't decrypt it. In 5 years, I can happily decrypt that traffic, and if you use the password, say if you use your banking password the same, and I happen to capture that, right? So those are so one is real, meaning this policy issue, we are just not allowed to do it. The other one is this perceived fear, like what happens if we do stupid thing like record the signal and somebody decrypts it and they say, oh, we use Cosmos for, for malicious activity, right? I mean, that's perceived fear, right? So those are probably the most important.
Okay, thank you. I have many other questions, but we can discuss.
Yeah, we can do it offline. Yeah. Thank you.
Thank you very much.
Sure.
Thank you. So now we have
It was too long,
arrived,
I'm sorry.
we have arrived to the time of our roundtable. That will be moderated by Professor Arlindo de Oliveira, full professor at the University of Lisbon, who I invite to come to the stage, and as well invite the panelists that will be
To converge, right?
at the roundtable. Thank you very much.
No, I'm glad. Oh yeah, we have to sit down. Yes, I'm sorry, Doctor. Goes where? Okay, right.
Oh, good afternoon. We have been given plenty of ideas to discuss. Thank you very much for a very nice presentation. And I had prepared a few questions to start this discussion, but I really don't need them because I got enough questions from your presentation. First of all, thank you all for being here, in particular you flew from the US. And maybe I will try to, first of all, I know very little about RF and radio frequency, so I apologize if I say something very, very wrong about that.
Somebody is feedback.
And the topic of the panel in the session anyway is not strictly on RF, but between communications and high-speed communications, low latency and machine perception, and that involves a lot of AI, machine learning, and so on. And we have here experts in both sides of the topic, so maybe we can have a discussion about this. And I will start with one question that you put, but I think it would be nice to have some idea, and I put this to the whole panel, which is we already have 5G, and adoption of 5G is relatively slow, maybe in part because it's too powerful for the actual requirements of most applications, and you are still planning on deploying 6G, maybe in 6 years or 7 years or so. And so my question, you made a reference to the killer app that really needs this low latency, high bandwidth. Any one of you can see these killer apps coming so that we can employ the full power of these wireless technologies? Anyone wants to venture a guess about this?
I don't see it. I'm sorry, I don't.
Well, you put a few ones there. I can.
Yeah, but it's not, nothing is, so if you look at, I mean, I just shouldn't criticize. I mean, you look at the cameras, right? I mean, you need to go to 120 or 240 frames per second to get low latency from the camera, forget about anything else. And even then, your latencies are nowhere near what we're talking about, like sub-millisecond. So anything that's based on camera is highly unlikely to require latencies that we're talking about, right? Is there something else? Maybe, but I'm not, I need to see what that something else is, right? Anyway, that's my...
There we are really talking about really, really low latency,
yes.
right? But maybe if we talk, you're talking about a few milliseconds latency,
yes.
right? But even if we talk about what can you get in 5G, a few...
Sure, but that, if you look at ultra low latency, right, it's sub 5 milliseconds. And I mean, I'm saying most of the stuff we see has a latency of 30, 50, 100 milliseconds.
Right.
So why do we push so much effort in, and it's I quote, expensive to do something in sub 5 milliseconds. Right? And, reliability of that is really sort of causing a problem to do sub 5 milliseconds. why are we putting so much emphasis there and not in other aspects of low latency? I don't know. I mean, but apparently we are the community that sort of tries to get it.
So I guess the problem is that the communications guide, you move too fast, right? I still remember the 2400 baud model that I used when I was young, and so you are just moving too fast even for the rest of the technology to follow. But you wanted to...
Yes, I think one of the use cases that will be important in the near future is the industrial and manufacturing. When you have these multiple robots, either in an assembly line or these convoys on the factory floor, this concept that we are working on now of this massive digital twinning, I think, at least in this scenario, I think really important the latency and all of this, because you have many things moving around the factory floor. And for example, you can try to avoid accidents and things like you were mentioning. And so having a virtualized view of everything that's happening in the factory floor, I think that's an important application. And I see both RF and video as important enablers, and even the combination of both.
Although putting that as a killer app is maybe a bit too much of a push, right? So.
It's one more. It's just one.
So, and what about the VR, AR, real metaverse, real immersion in distant space and so on? That is something where we are very sensitive to low latency. Do you see that coming in the next 10 years or so? Or?
Yes, that's one of the applications we have been talking about even in these European projects that are starting recently, such as Converge. This telepresence and virtual reality. Yes, that's something I think at least several people are talking about this application, and I understand that the real-time requirements are really tight in that kind of application.
If people start wearing glasses and walking around with AR glasses, you'll need...
Exactly.
Okay, so let's leave this low latency thing for later while we think about it. And let's go more to the perception part and so on. So we now have these machine learning models that can do perception in real time. Really, we have a project, a Magellan project, on we are developing these perception models in edge devices, and it works rather well. And we have here some people that work in this area. Do you think we'll see a revolution in the way we manage cities? And you have shown a few examples. I mean, are we going to have cities instrumented with these detectors and know where people are and vehicles and so on, interconnect all this? Because this will be a massive project, right? I mean, this will definitely get us a lot of work to be done in this. Do you see this coming? Do you have any projects in this area or any?
Well, say that the amount of data that we can collect from the cities, I've said before, it's so large that can help managing several aspects in a town. Besides the traffic, that's one very important issue. It can also help identifying anomalies. As I think Ivan told everything during his talk. He identified most of the challenges.
Of his talk and I'll just
he identified most of the challenges that can be, that can benefit from joining these two things, the communications and the data coming from cameras that are a type of sensor, but other types of sensors we are dealing with in Converge, that we are talking about joining image and RF sensors that can help solving aspects, for instance, that we cannot solve with cameras. Because, for instance, with cameras, we have this issue of different changes in light, for instance, that can affect the results, and that maybe can be solved and that are not that affected if we are using RF signals. Okay? This can be used not only...
You mean as sensing?
As sensing, yeah, of course. So the idea here is to try to avoid some of the problems that we have with one type of sensors and bring the information from other ones that mixed together can help constructing the full view of the city, of the scenario that we are dealing with. Of course, there are several problems here because we don't have a way yet or a solution how to fuse all this information. Okay? Besides the amount of information that we are collecting, we don't have yet a way of fusing the information coming from these different sources and different formats of data and so on. So I would say that challenges are still quite important.
Are you talking about lack of processing power in the center, or?
Yes.
Because those digital twins, I mean, they are working, right? So you can fuse and get the boxes and so on.
We have to synchronize data, for instance. That's one important aspect. And then also the computing power. Okay, devices are getting more sophisticated with more computing
But you can push
power.
that to the edge, right?
Yeah.
Because you have more powerful edge devices and so on. So.
That will enable to have faster faster answers to identified problems, I would say.
And do you have any big projects here, for instance, in Porto or in a Portuguese city where we are going large scale with that? I mean, in New York City, I can see we have fairly large projects, but do you have any projects here? Or?
Following what Paulo was saying, I think it's important that we move a lot of the processing to the edge because we are getting information from a lot of sensors distributed and with a network that is moving. For instance, we have cameras in cars, we have cameras that are moving around. So we need to, even if the communication infrastructure is able to support a large band, ultra-wideband communication, the amount of data is so massive that we need for sure to have local processing or, let's say, regional processing in some hotspots so that they can transmit data at a higher abstraction level. Otherwise, no communication infrastructure will be able to have I don't think it will be feasible to have an overall picture of everything. It's much more going to have local pictures of things that are relevant and to transmit all that information. I think that's much more what will.
But don't you think that the ambition in the end, if we get around RGPD and so on, GDPR, is it to have a digital twin where you have a model of every person, every car, everything that is in the city, just use that to predict everything? Don't you think this is the medium-term ambition? Or is it too ambitious? So we'll never have that.
It would be great to have that for sure. And I think that all researchers have that ambition. I'm sure. I don't know how the path to that will be. If we should move right to have that as a target, if we should instead define intermediate targets that don't go in that direction directly.
We have things like this for factories and for enclosed spaces and small spaces, right? Going for a city-wide level is harder. But even at the factory level is already a challenge, right? So I think this, but there are not projects, there are products that actually do this, right? And this is.
But in a factory, I think that we have a digital twin with a purpose. That is how to improve the efficiency of the production line and so on. So when we build, let's say, a digital twin of a city, or we need to understand what are the goals, what are the targets that what are the measures of efficiency that we are trying to attain. So
there are a few obvious ones, right? Energy consumption, travel time, and so on.
But
the question is whether those objectives are enough for us to get to the trouble and the challenge of building such a thing. Right? But I mean, the European Union has a number of projects that are relatively ambitious in developing digital twins in this sense, and I guess the US must have something similar. Otherwise,
there is. I mean, you saw that we do have the objective of building a digital twin, at least for these 3 testbed areas that we are talking about.
yeah.
But it's still, I mean, we don't have tools to do multimodal combining of sources. Right? I mean, that's still sort of nascent at best. And if you think that the objective is to do a full digital three-dimensional twin of everything that's happening dynamically in the city, that's, even if it's section of the city, right, a couple of intersections, we're still far off. Just to give you an example, we can't even predict if cars are going to continue straight or turn left until they start turning. It's really, really hard unless we get some feedback from the car itself. And so that's actually one of the sort of ideas is, can you combine, most of the cars these days use Google Maps, right? So if Google could only give us that feedback that his trajectory is going to be this, then you could do a lot of creative.
Yes.
So danger is that Google is going to do it. So, that's because they have way more information.
But I guess my question is, I mean, if you put this from a vision perspective, should we, the scientific community, propose this, aim for this, or you think it's too ambitious and let's just keep with our smaller...
We should aim big.
Yes.
I don't see it.
I think we should aim to
Aim big. Yeah. There's no reason not.
high aims, I think. But
It will take some years, but we'll get there.
No, I mean, I was drawn because of the pandemic first and because of Next Horizon or whatever it is. And so it would be nice to have some large-scale projects that can serve as engines of development, and then we can use all these technologies. Because otherwise you'll have the technologies, but they are moving so fast that you don't have applications demanding enough to use all these, right? I mean, you have this ability to recognize things on the edge, you have these low latency networks, you have all of this, but in the end, if you cannot put all of this together, they are just toys, right? It will not really make a difference. Yes.
Yeah, there are, so in this Smart Networks and Services program of the European Commission, so this started recently with a phase 1 project that started this year. And in the first phase, there were 35 projects. One of them is the Terra Meta, which is on reconfigurable intelligent surfaces in sub-terahertz, which we are coordinating. But there are several strands of projects, and some of them are more integrative. Some are more testbed related, and for example, one of them is the EXA-X, which it is now at EXA-X2, which is exactly what you were saying. It's a project that tries to understand everything that is being done around the area and gather all the use cases and applications and so on, and tries to see what each project might contribute to, for example, in this case, to the 6G vision. And so try to make some alignment among what is being developed in the several projects and several partners and so on.
So the other thing you made a reference to, and it still is the autonomous driving and the possibility of having autonomous driving, possibly direct connection to a central server and so on. Do you think this is the way to go, or the cars will drive by themselves without connecting to the central server? What do you think will be the technology that will win in the end?
I mean, argument is for connectivity to the infrastructure because, the story goes like the self-driving car can only be as good as the best driver, right? And there are situations where you simply don't have situational awareness enough to avoid accident, right? In other words, if somebody is speeding up at 100 miles an hour on the 25-mile-an-hour street and you're going towards that intersection, there is no physical time to react before you get hit, unless infrastructure tells you, hey, there is an idiot who's driving 100 miles an hour down the side street. Right? So logic says we should talk to the infrastructure. But, legal issues with car manufacturers and who's going to be blamed when things don't work, I think will prevent this from happening anytime soon.
And are there projects in this direction with car manufacturers and so on? Or?
So they are interested, but you talk to manufacturers of this world and they will not want to share the blame for things. So therefore, most of them are now saying, oh, it's only what's in my car. Meaning the sensor input from my car, sends what I see, that's going to be the mechanism for self-driving, right? Which again, I mean...
Because that would be a nice killer app, right? I mean,
that would be, yes,
that would be a very nice killer
absolutely.
app, right?
So we are actually trying to sort of look into this notion of mobile devices generating massive amounts of video, sending it in, and not just video, but radars in the cars and lidars in the cars, they're generating massive amounts of data. So if you can push that out and combine it in motion, which of course you pointed out, synchronization is a huge problem. If you can do that, that's going to give you an amazing ability to see what's going on.
I mean, if you couple that with the digital twins and so on, then you have everything, right?
Yeah,
you can reduce sinistrality to zero, basically,
yeah,
right?
That's but
There is something interesting here. For instance, you said that manufacturers are not wanting to provide their data.
No.
But in the future, they may be obliged to. Because if this is useful for the society, why not to have?
I agree. I
Not to
mean,
have
in Europe, that's
laws
probably
that-
possible. In the US, I don't know. I mean, it's going to be hard to get that.
So before, this is completely off topic, but I once read a science fiction book where you were able to send a few bits of information a few seconds back in time. And so that stopped all accidents because, they just use the channel to tell, you are going to die, and people change it around. But we are still not there, I guess. I mean, latency is still positive, right? It's still not negative. Anyway, so, Aníbal, you are very involved in robotics and marine robotics and so on. Does this advances in communication also help you there, or the water is terrible and you cannot do anything with that? So.
Underwater is quite difficult because for long distances there is no high bandwidth. Right. There's no possibility of having that. But anyway, all advances in communications are useful. For instance, in short range wireless communications underwater are still very relevant. For instance, for operations close to infrastructures or things like that. So the advances in communications are quite relevant on that area too. But I think they are different from the ones that are in the air. I think the situation is quite decent. But going back still to the autonomous driving and relating to our previous question about the infrastructure, I think that once everything is autonomous, the infrastructure will exist, for sure. Once every car in the street is autonomous, and I think in the future...
When will that be?
I think that it will happen, for sure.
Yeah, I know, but when?
I think I won't be present, but while there are still, and I think the major problems, and there will be a lot of issues to solve when we have to the coexistence of autonomous or more autonomous driving cars or self-driving cars and people driving their own cars, because I think that will be, and it will last for many years. I think all of us want to have control of our...
We want to make our own mistakes,
yes,
right?
because we already have, let's say, buses and public transportation, and there are always people that want to use his or her own car or bike or motorcycle to move around. So,
for fun.
but people will always resist to leave control to the infrastructure, whatever it will be. So it will take to...
Yeah, the level 5 autonomous driving without steering wheel or pedals will maybe a long way, right? Yes. But anyway, so one of the things that all these techniques, I mean, digital twins, remote, whatever, they always face significant challenges in what regards privacy, in the sense that people are very afraid that it invades privacy, and to be fair, that they can really invade privacy. And Europe is very strong on this because we have all this regulation, GDPR in particular. Do you think this will be a roadblock to develop these technologies, that will be simply too hard, and maybe the Chinese will get there first or whatever, because of these privacy issues? Or do you think there is a way around this and we'll be able to develop prototypes without violating, at least explicitly, these regulations?
I think that anonymizing data has also always been an issue, even for in medical.
And it's also impossible, right?
Yes.
But okay, if you do some computing in the edge, for instance, with the cameras, as Ivan also showed in one of his slides, we can even anonymize the information before sending it.
That is true. That is true. But still, if you know exactly where the person left and where it arrived, and
You can figure out.
and there is a person that does that every day, it's very likely it's the same person. So that if we face pushback from regulators or from public concerns or whatever, this will face difficulties. Do you think we'll face those difficulties? We'll be able to overtake them, or because the problem is theoretically you can anonymize, right, on a superficial level. When you go deeper, then it becomes much harder, right? Because and the question, and you can already see there's a significant lashback against even AI, right? Because people are worried about, and in China, privacy is pretty much gone. So do you think we'll be able to navigate around these regulations, or we have to change whatever? Or because I see many people complaining about the difficulties in complying with the regulations and developing these things, right? And you made a reference to that too. So.
Yeah, it's really hard. I think it slows it down. It doesn't prevent it from happening, right? We anonymize stuff and we put it out there. So I think the only issue is really in slowing it down. My sort of personal, I don't want to say complaint, but personal observation is that Google knows everything we are doing. Your cellular provider knows everything you're doing. Why do we believe that they're any better than say, a researcher sitting in some university somewhere? I mean, that's not, I would argue it's the other way around, right? I mean, even if I know who you are and where you go, right? It's not I'm not gonna change anything in your life, whereas Google or whoever is, the provider. And I'm not just speaking on Google. Of course. I don't think it's wrong. It's just these companies have to collect this data. And personally, if you take away my Google Maps when I'm in Porto and I don't know where to go and how to do it, I'm not sure I would be happy, right? Even though I Google knows I went to whatever museum because I looked for it, and right, they know pretty much everything I'm doing.
In Europe, there is this strong directive and so on. In the United States, it's not so uniform, right? Some states do have that, like California has a fairly restrictive privacy law, but other states are not so much. Do you think the US is going the same way as Europe by imposing these privacy laws more generally?
There is, but I don't think they really work. I mean, this is perception that we have. Oh, if I tell them to forget me, they'll forget me. No, they won't. Right? There is no, how do you verify that they forgot you?
And removing them from the data from the models is even harder, right?
Yes, exactly. So, it's like we believe that there is some law that says, so, in other words, it does prevent them from doing massive abuse.
Some obvious thing, right?
Right, but I mean, they still know. So if you're talking about knowledge, they know. It's just that they're maybe not abusing it. And that's okay. I mean, that should be norm. Anybody is abusing data, they should be punished or something.
Yes, I think this is more of a political question. And as you were saying, at the end, you will always be able to find some pattern in the data, some metadata that allows you to find out some more than what we have superficially taken out from the data. So as a researcher, I don't pay so much attention to that question, but by the way, we are obliged to handle this kind of question in these projects by having an ethics board, ethics task to analyze the implications of privacy and the personal data and these kind of things, data management and so on. But what I would like to have here is that I see as, and related with this topic, I see as very important the fact that this convergence between communications and machine perception, in some way, computer vision data, which you obviously will have access to faces and personal traces of people and so on, which are naturally sensitive data, right? But when we start talking about communications, signals, these are, if they are lower frequency, even millimeter wave, you don't have this kind of accuracy as you have in a camera to, for example, recognize a face, or even recognize, maybe you could recognize a person by the walking pattern. Maybe something like that could be possible. But in a way, I see this as interesting because this is allowing to create some less privacy-sensitive sensing than what the cameras can do. Although the cameras can help in the development of the algorithms that will make this RF sensing more accurate.
So you are suggesting that a way to address these concerns with privacy is to rely less on cameras and more on the other sort of data that you are discussing.
Yes.
Do you think that's a real possibility?
I think
It's the way to go?
That's one way.
Yeah, no, it's possible. I mean, again, the question is this notion of privacy. I see it more as in sort of slowing down what we're doing than as a real issue, right? And it's in the sense that we are now forced to do things with the data before we release it. And then, of course, some people use it as an excuse not to share their data, right? Then that creates even bigger problem. I mean, I'm now refusing to review papers in the conferences that don't reveal the data. I just don't know what I'm looking at. I mean, it might be those people are fine. I mean, they're probably doing good things, but how am I to verify? How am I to even understand what they're doing unless I have access to that data, right? And then, you know, if you look at all the papers from Microsoft or Google that use their massive stuff, I mean, how do you judge what they're doing? You can't, right? So it's same is true for anybody using private data that we don't have access to.
May I add something?
Sure.
Luis was saying that, okay, with the RF signals, maybe we can do some kind of anonymizing of the data that we cannot do with cameras. But when we are able to track people through old paths, you are not anonymizing anymore. Because if some RF signal is able to identify that I'm going out of my house, and then it can track me all over my path.
It does not entirely solve the problem.
It's not solved.
So the other direction that was referred here, and this gives the word more to the RF people, is the other way around, sort of using machine learning mostly to improve spectrum management and to improve negotiation and so on. So we'll see developments in that, so even more advanced spectrum management technologies than what we have now, and therefore higher bandwidth and lower latency. Are we going there?
I mean, there is a strong interest in regulatory bodies in the US to enable something like that. The only question is whether, when you propose something, whether they'll accept it or not, right? I mean, it's all fine until you get to a point where you can potentially screw up some major service, right? So unless we can show that this is feasible and doable without harming the primary user of spectrum, you know, look at how long it took for actual lightly licensed bands to become reality. Right? It's only now you're starting to see, for instance, CBRS deployment in the US in say, universities and stuff like that. And we've been talking about this for 20 years, right? The database-based stuff.
Because if I understood what you were describing, you can put additional levels of intelligence in the way you manage the access to the spectrum and therefore improve the usage of the spectrum significantly from what we have now.
Right? And conceptually, we all agree that that's doable. The question is, you know, when we make mistakes, what happens? And we all make mistakes. So, you know, I'm talking about algorithms as well as humans. Right. You know, the first serious mistake is going to kill the whole concept. Right? Because somebody's, you know, just think about this notion of airplane mess that was caused by the filter, the old filters on old airplanes for coordination for landing ILS and instrument landing systems.
Right.
You can't deploy now certain bands, 5G bands in the US near the airports because
Of that.
potentially you can harm the old instrument landing system. And of course, you understand why that's a problem. I mean,
Of course.
if the
no,
plane goes down, then
Yeah,
we
not
are
good,
done.
not good.
Right? Nobody will ever allow us to do anything else.
Will those technologies will be included possibly in 6G or is past that? Not enough.
Maybe it's too early for 6G, but or maybe there will be something. I mean, I don't know.
One of the things that in city we are higher frequency bands beyond 100 gigahertz. For example, in this European project Terrameta, we are looking already into the 140 and 300 gigahertz bands, which when you look at the atmospheric attenuation are not that bad, as for example the 60 gigahertz where high attenuation because of oxygen, I guess. Those, you don't have that. So there is quite a lot of research already on the development of RF devices and antennas and so on.
If I remember well, that maybe not exactly that range, but that sort of range of frequencies also enables you to instrument the streets, to understand what's going on in the streets and the spaces, right? Because the waves are so short that you can actually see around corners and stuff like that. Are there any projects on that, on using that sort of ranges to do instrumentation, to do perception, I mean, to do sensing, right? Are you familiar with that? Or?
I think so. I think there are. One of our partners in Converge actually nightly actually looking into that way of bending around corners around 200 years. So these sub-terahertz are very hot right now. Are looking.
Because it can be used not only for communication but also for sensing, right?
Both areas
Are interesting. Okay, so before we open the floor to questions from the audience, any one of you wants to pick some of the topics that we heard about or some other topics for discussion here? Like to, now that we have those technical problems solved, anyone else wants to raise some question or answer some question?
I think that one very interesting thing that I think will happen, and all these convergence between communications and perception, that I don't understand anything about communications, but I think there's the opportunity to have much richer data about the environment from the, let's say, higher frequencies, and all that data will for sure combine with the more traditional vision-based and more understandable for us as humans, which are our common, more our sensing. And it might also lead to solve or partially solve all these data protection problems, as Luis was saying. If you don't understand, don't see the faces, although you can detect patterns and all that, they are much less understandable for us. Of course, machines now have all these artificial intelligence, let's say, capabilities, but I think it might help us circumvent all these difficulties that Europe and US have, all these regulations that in fact, in the future might, let's say, put a couple of hurdles on our development as compared with other countries which don't care less about all these problems. I think in the future that might be a problem for us. I think for the, let's say, more these open societies, I say.
So before we open this, so let me just stimulate you with an idea that has been discussed in a few articles about this, which is this sort of digital twins, but I mean, even if it's not a full digital twin, even just the data from the cameras and sensors also enables you to do a sort of time travel that has been experimented with, in the sense that, for instance, if you have a murder in a place, then you can sort of go to, and then people flies away, right? But then you can go to that place and just check not only where the people went, but also where the people came from, because going back in time, so you can do this. And there are a number of pilot projects in this, mostly using drones high up, but you can also do it in other ways. Is this an application that is also of interest for, I mean, police and government and so on? Are you aware of any initiatives in this domain or not? It's a separate thing.
Sure. So we actually have an interesting problem, not problem. The requirement at the university is that you, after 60 days, if you deleted something, that has to be permanently deleted. So in other words, in theory, at least, we are not allowed to keep the data. If somebody says, oh, I want to delete the video from 60 days ago, we are not supposed to keep it after that. Now, of course, that doesn't necessarily apply to data sets, right? I mean, data sets are there to be forever.
Right.
So, and same is true for police. I mean, for how long do you keep the data, right? And what does it mean societally? What does it mean that somebody knows that you were at some point in space and time? And for how long is that relevant information for whatever, right? I mean, because that, again, can be abused in different ways. Right? Both as private citizen, you can start asking for certain questions to be answered by somebody having this data, or, as you said, police or whoever else. Right? So that's a very interesting societal question. And to me, personally, my biggest question is, what are the societal changes that this will all cause? Just think in some hypothetical sense, what happens if and I'll use Google as an example, not because Google is doing it, but because I have a phone that has Google on it. If it pops up at 8:30 in the morning and say, you have to go to work now because we optimize the traffic, and now is the perfect spot for you to go. I mean, and if I don't do it, what happens? What's the penalty? Or if I do it, right, why am I doing it? Maybe I woke up angry this morning and I really don't want to do it.
But from the point of view of security and crime prevention in cities, it's a really powerful tool, because you can really go forward and backward. I mean, people usually take care when they run away, but not so on the other way around. So you can go forward and learn a lot about what happened, where people came from, and so on. So
yeah.
It's
but it can be also abused, so, you know.
No, it can certainly be abused. I mean, it can be used for good objectives or with bad objectives. Okay, very good. So I think we are in conditions to, if anyone wants to use the opportunity of having the members of the panel here and wants to ask a question, maybe some of you want. Not all at the same time. Oh, there you go. Do you have a mic or not? Maybe. Oh, there we go. There's a mic there.
Much for this very interesting debate. I think that you have already mentioned, but not very deeply, the aspect of cybersecurity. So security concerning people, yes, it was really well addressed, but I didn't hear much about cybersecurity and neither about the robustness of the AI algorithms. But you mentioned that it's necessary to detect anomalies that the AI algorithms may have, but I didn't see any specific mention of robustness, explainability of AI algorithms, or cybersecurity. And I think these are really important aspects. So if you would like to give some ideas.
Right. Do you want to say anything? This is a good point. Do you want to say anything about the explainability of these black boxes that we now deploy as models?
Yes. That's a big problem that everyone knows about, and we are not yet sure if we can trust in the results that those AI algorithms provide us. So, as Teresa was saying, this explainability it's quite important for us to trust on the information. So this is really, as Teresa pointed, the research aspect. Besides, of course, cybersecurity, because we are dealing here about lots of data, and if this data is stolen from somewhere else, even from cameras, on the cameras, but the device that store them. This is, of course, a quite important challenge, but that's something that is being dealt with already in several applications, okay? Because we are dealing with data, we are dealing with banks, we are dealing with health information and so on. So this is important, and the research community is already addressing this, I guess. And the aspects of explainability is also a hot topic in everything related to AI. Okay? So there's still a way to go, but people are doing some work on this.
Yeah, I could talk for hours about the explainability or lack of it on models, but I guess you made the major point. On the cybersecurity front, the key, I mean, maybe there, but one key difference is that one thing is to secure a server or a mainframe or a group of servers. The other thing is to secure 10,000 cameras running obsolete software and so on. So that is quite, and as you know, almost anything can be infiltrated these days, even pacemakers, right? So do you think we'll be able to solve that, or those cameras will just be bought on the service of the dark side fairly soon?
I'm sure they will be on the dark side soon. No, I mean, joking aside, the trust or explainability, right, or trust is really not there yet. I mean, just to give an example, we anonymize stuff, but then somebody has to watch every single frame and make sure that your face doesn't show up in one frame, right? And it's really painful if you have to go through like an hour of video frames to make sure there is really no face showing up in any single frame. But that just shows you that we don't trust it, right? So I don't think it will take a while to get the trust. Even if we have provable things, it's going to take a while. I don't know, maybe because of human nature, but we all know that our algorithms are not perfect.
Yeah, because there are the two issues, right? Is the privacy and the security, and for people to feel safe, you really have to be convincing on both fronts, right?
But on the other hand, if it's all open data sets, right? I mean, then maybe it's not as bad, right?
In the system, fake data.
Sure. So that is true. So we do have to sort of label properly all our data, have reasonable guarantees that the data is not compromised in any way. And that we know how to do, right? Meaning we just often don't do it, but we know how to sort of make sure the data was not altered by third parties before, wherever we store it, right? But unfortunately, we don't do it often. And I think actually one thing that I don't understand is why don't we have, and maybe it's, I was told not to use that as an example, but I don't have a better one. The Lena, the JPEG model, why don't we have that? I mean, why is our community, and now I'm talking about, say, pick your favorite flavor of AI and topic that it's sitting on top of, why don't we have Lenas for various things? That I don't understand. Or at least somebody trying to make it. Maybe it's wrong, maybe it's not perfect, but it should be there, right?
Yeah, on the explainability thing and also on the confidence thing, I think we are not there yet. I think the models that we have now, well, first of all, they have a hard time explaining themselves. They don't do it, basically. But even possibly more seriously is that it's hard to get a good estimate of the confidence that the models have on whatever the classification. So, and this is something that people are working on, but it's unclear how it's going to move, because models, these LLMs, but also CNNs and so on for computer vision, I mean, they sometimes do a fairly good job or even a very good job, but they cannot assess the confidence that they are labeling things, especially in exceptions and stuff like that. And this is something where I'm not familiar with all the research, but it's something that is not an easy task. So it's very hard to to have good estimates of the confidence of the models. And this is something that, of course, is also having impacts in the self-driving cars, because you don't have this, because otherwise it could just stop, but it has impact in many things. Good, thank you. Any more questions or points to be made?
We have discussed how telecommunications will help sensing by using these RF waves. We have discussed how RF sensing and video sensing can work together in order to enable us to have better mapping of environments. But we did not yet discuss how communications could benefit from sensing. So if the communication systems can see, how could it behave so that it could perform better its main function of providing communication? Would you take advantage of this new capability for improving communications? Ivan, Luis, I'd like to listen from you.
Sure. So you just think about it. If you have full situational awareness and you know where you are in physical space, it makes beamforming trivial, right? I mean, of course, it's a chicken and egg problem, right? But in theory, at least conceptually, if I know where I am and I know where the base station is or whatever infrastructure element is, I can aim my beam there and it can aim at me if it knows where I am. So, we solve one of the open problems in the communications, right? Which is how do you do beamforming efficiently in a high mobile environment?
Yes, I think in these kind of scenarios, if you have cameras and you can track what's happening in the scene, so you can track movement and so on, you can also anticipate blockages. So you track and you can predict that this trajectory of this device or this industry car or whatsoever is going to block your connection. So you anticipate and you make an handover to another access point, things like that. So I think communications can benefit a lot from the vision, especially because these higher frequency communications depend on the vision side, on the line of sight.
So the beamforming technology is used actually or actively used in some of these cases that you made. It is.
Yeah.
You know where the receiver
Beamforming
is,
is active part of most of the modern systems, right? And beam tracking is a non-trivial part of communication infrastructure, meaning trying to figure out what is the optimal beam assignment and stuff like that. Right? So,
yes, and papers on the literature are like from 1 year ago only, like exploring this, substituting like the channel state information by optical cameras to try to improve the communication. So this is a really recent topic, right?
I am reminded that not long ago, maybe 1 year ago or whatever, we had a security problem with one of our telecom providers, and it was very bad because they invaded a lot of levels of the stack of communications, including, I think, all the way to the radio, to the software radio thing, and so it took several days to get things back to work. So as we get more and more dependent on the software to do all levels of communication, we also a bit more susceptible to attacks, right? Because when you attack, it's almost as if you destroy the hardware, even though it's not exactly that, but it's close to that. So this raises the security issue, becomes more critical because now you compromise many levels of the communication stack. Maybe one last question before we close the session. We have one there.
there is one way.
Hello, good afternoon to you all. First of all, congratulations to Professor Ivan for your development of the testbed of Cosmos. And I have two questions. The first is, as your testbed has a lot of nodes and equipment, do you have some kind of energy concern about energy efficiency? And second one is about the the prevention of accidents, not in the city, because you have screened the intersection of the streets, but do you have the intention to apply that technology in motorways where the accidents are more fatal, and the communications are important to communicate between the cars, especially when there is weather conditions not good, like fog and so on? Thank you.
So I guess it was directed at me. So the first one is actually, I talked a little bit about this ORAN, which stands for Open Radio Access Network, and that's heavily softwareized, right? Meaning everything is software more or less, except potentially just the RF front end, right? That's a huge problem. Because if you look at, and of course, in testbed case, you can argue, well, we are sacrificing energy consumption for programmability and ability to do experiments, which you sort of have to generalize in some sense. So therefore, power consumption is not a critical part of that. But in the ORAN world, it's really that's one of the main issues right now, where you're seeing that monolithic base station is a few hundred watts or maybe a kilowatt, right? Depending on the size. And then you replace the whole thing with 4 servers, each of 3 kilowatts, right? So, I mean, that's like, we have an extra zero in there that needs to be dealt with. And that's actually something that the whole community is now trying to sort of address in some ways. And unfortunately, it looks like the way it's going to be addressed is to sort of introduce accelerators, which are custom components, killing the concept of x86 architecture doing everything, right? But that's a separate story. Now, as far as the second question about the highways, so that third testbed I showed as part of smart streetscapes deployment is actually a section of the highway. And I drive that between our main campus and where my lab is. So I drive that quite often. And you drive it at 100 kilometers an hour in that section. Even though it looks like it's going through the city, it's not. It's a proper highway. And so the idea is to sort of look into these things where you're dealing with fairly high-speed traffic and potentially, fog or whatever else environmental conditions you have. To me, the biggest problem is what's the actuation? I mean, how do you, yes, you can detect that I'm doing something wrong, but what do you do about it? And maybe we can get to a point where all these speed trap cameras that we have all over the world, right, will suddenly not just issue you the fine coming in the mail 2 weeks later, right? They will maybe send you some message, hey, you idiot, slow down, you're doing something wrong, or, slow down because there is somebody in front of you who you're going to hit.
Or just press on the brakes.
Well, so actually, that's actually one other question. Do we put in the cars the kill switch, right, where it shuts down your car if you're doing something wrong? I don't know, maybe. Right.
Okay, very good. Thank you very much. Thank you for your contributions and thank you for your attention.
Thank you very much to all the panelists and especially to Professor Lindsay Oliveira for maintaining this very interesting debate. Later on, there will be the opportunity to continue the discussions during the cocktail session that we will have. Now we will continue with the presentations and I have the pleasure to introduce Rui Campos, the head of CTM at Inesc Tech and also professor at the Electrotechnical and Computing Engineering Department of PhilP. And Rui will be giving a presentation to unveil some of the research that CTM is conducting in the relevant fields that we are addressing here. So the floor is yours, Rui.
So, good afternoon, everybody. First, before going to the presentation, I need to give some, or to make some acknowledgements for this organization. I would start with thanking the presence from our Secretary of State for Digitalization and Administrative Modernization, Mario Campo Largo. Thanks for providing this great video on the vision that the Portuguese government has around these issues. Let me thank also Professor António Cunha, that I think is not yet in the room, but he's arriving, that will be speaking after me here to end the session. Then also thank Professor Rui Calçada, that opened this session today, and the Dean of FIOP, and joined us. Then Ivan, thanks for coming all the way from the US to here and to give this nice, sorry, the slides are going, not, I shouldn't be there yet. So thanks for coming and for this great presentation. Professor Arlindo Oliveira, thanks for moderating this great panel and for coming from Lisbon to join us. Thanks for that as well. Professor José Manuel Mendonça, that I think is joining Professor António Cunha, so he's not in the room currently, but which also gave a very nice talk in the beginning of this session. Thanks also to him. And just to quickly finish, also thank Professor João Claro, that is the Vice Chairman of INESCTEC and CEO of INESCTEC. Thanks for being here as well. And thanks to the panelists that were part of this great panel, Luís Pessoa, Paula Viana, Aníbal, and also Ivan Seskar. And just to finish, thanks to our colleagues that will be doing some demos afterwards. So when we go to the Port of Honor, we'll have some demos there, so you will have the chance to see some of the works that we are doing in these areas, communications and machine perception. And last but not the least, the organizing team, especially Professor Mel Ricard for organizing this great event. I know it takes a lot of work to do. We were discussing this yesterday and today. So thanks a lot for organizing this fantastic event, and specifically also to Filipe Teixeira, to Joana Tavares, Maria Teresa Andrade, and Pedro Neto for this great endeavor and involvement in this organization. And finally, thanks all of you for being here. It's a great pleasure. Today is a happy day for us because it's the 11th event of this type. We started in 2012, so a long time ago. And it's really nice to see you here and interested in these topics. So, the acknowledgements made, I'll go to the presentation. I'll try to give you our vision on these topics. Personally, I'm really confident that they will mark the advancement of the state of the art in the next years. And let me start with some definitions that you were seeing before. So, first of all, of course, communication and communications, everybody knows, I think, what they are, but and I would like to make also the connection between the digital systems, the artificial systems, and humans, because I think we are touching the human capabilities. Technology is evolving into that direction. Of course, with the artificial intelligence regarding the machine perception side, but also communications are also evolving into that direction, in my perspective, and you were discussing this over the panel as well. So, of course, communication is transmission or exchange of information, knowledge, ideas. This is more, of course, related to humans, but what matters for us is electronic media, and specifically for CTM, what matters more precisely is wireless. Perception, it's maybe not well defined in your minds, I guess. So some of you might know it very, very well, but maybe perception is not something that we heard every day. So, and I would highlight these two things. Become aware, so, and you discussed this also in the panel, become aware of your environment, where you are, who are we communicating with, and so on. And the senses. So humans have senses, and technology is increasingly incorporating senses, different sensors like RF sensors, video cameras, audio, so microphones and so on. So we have these two things, awareness and sensing, that I think are very important to highlight in terms of perception. And machine perception is basically trying to imitate this in humans, right? With respect to humans. So, and this is actually the definition that you find in Wikipedia, but by the way, I was checking this not only in Wikipedia, but this was the great definition that I could find. And as you can see, machine perception is basically interpret data in a manner that is similar to the way humans use their senses. So this is actually what we are trying to do with technology, from the machine perception side, but also now combining this with communications. So let me now talk a bit about the two areas in separate. So of course, I think everybody knows here that the two areas evolved along the time in separate tracks, let's say. So communications came all the way from the telegraph in the 19th century, sorry. And then we went to the telephone, radio, and actually Rui Oliveira from the board was remembering me today that today is the 10th of May was the day that Marconi did the first radio transmission in that decade. So, and we went all the way to internet, wireless technology, and then we arrived today with 5G and Wi-Fi 6. But all along this track, we didn't have quite much machine perception in communications. I would call it basic machine perception. We had routing, for example, we had rate content adaptation, we had beamforming that was already mentioned here, but it's still done in a very rough way, not a very precise way. So we still lack a lot of machine perception in communication. That's precisely what we are searching for now, in combining this with the knowledge that comes from machine perception. And machine perception also evolved separately from the 60s with computer vision till today, edge AI, that we talk a lot here. Edge AI or edge computing, I would say it's similar. So, but these two technologies or these two domains evolved separately. And I'm saying here they're separately from communications, but the opposite would apply as well. So what we are seeing, and this is of course a bit of our vision, as we also discussed here today in the panel and in the previous presentations. If you think about humans, perception and communications are working together, right? We communicate to perceive the environment, and we perceive the environment to communicate better. And you can just think about some examples that you will come up with this conclusion. And machines, as I was saying, are evolving in the same direction. That's our vision and actually a fact. We can see that as a fact nowadays. And this will happen in 6G and next generation networks. Not only in 6G, but Wi-Fi 8 or other technologies that will pop up. We are seeing this spreading a lot and integrating sensing and communication in the same technology, and with that, combining machine perception with communications. So, and why this is happening now and not before? And as Luis and other participants in the panel were saying, this is very recent. We are trying to combine this in the recent years to reach the next level. Mainly for three reasons. One is what we already mentioned quite a lot here today, the moving towards higher frequencies. If you look at the spectrum, we are going to the direction of visible light communications. And this is actually happening and will happen in the future for sure. And this movement towards higher frequencies will imply that we depend much more on line of sight communications. And there is a third reason, let's say, which is something that I personally think will revolutionize communications, which is semantic communications. Not the bit by bit that we do today, but the semantic transmission of information. So like we do in our human conversation. I can tell you, I have a car, I have a vehicle, I have a voiture, let's say, and you understand that it's the same thing, right? But if you look at it as from the bit-oriented transmission, it will be different things. So this is the way people in the community is looking to save bandwidth. And this will, I see here, applications not only for the next generation applications like VR, augmented reality, metaverse, and so on, but also for those scenarios that we were talking about previously regarding low bandwidth availability that we can trust in this paradigm to exchange information. And of course, this will depend on machine perception, a lot, okay? Because you need a lot of AI and a lot of machine perception to do this. And the opposite will also happen. So networks can and will be used for machine perception, as was already extensively discussed today, this afternoon. Machine perception will be enabled by the networks themselves. So you will have antennas, you will have them operating as radars and as sensors of the environment. So the second part of the slides is just to let you know what we are doing. So this first part was mostly letting you know what's the vision for us, what we see for the next 10 years or so. And now I'll try to show you what we are doing at CTM, and that we are really in good position to combine these two things towards this objective. So first, the mission of the center, just to let you know what we aim to. So this is something that we have written in some places. So to research and develop advanced systems and technologies. This doesn't say much, but the important part is the second, third, and fourth line. To enable autonomous communication systems. And again, the connection between perception and communications, the autonomous keyword. Knowledge extraction, so machine perception again. And immersive, ubiquitous multimedia applications. So you can think about virtual reality, immersive virtual reality, metaverse, which will be a lot of it, and so on. And we are doing, just to give you the only slide with figures, but just to let you know how we are pursuing and what's the critical mass that we have for this. So we are around 100 researchers, 92. One third of us are PhDs. We have around 50 PhD students. Every year we have more than 100 master students doing their thesis in these two domains, let's say. Also trainees that come to learn more about this. And finally, people coming all over the world, let's say, from 9 countries. Of course, most of our researchers are from Portugal, but we have several from abroad. And our scientific areas, I would summarize them as these 6 that you can see here. So we do a lot of computer vision, we do a lot of sound and music computing, and we also do information processing in general, and these 3 are mostly related with machine perception. And then we do microelectronics, reconfigurable hardware, and wireless communications and networking that go into the other direction, communications, but also some of those are also related with like configurable hardware, where you can do something for edge AI, for example. And just to let you know very briefly some of the topics that we touch in more specific terms. Regarding computer vision and machine intelligence, we touch automatic object detection in images and videos, automatic classification of regions of interest, emotion recognition and content generation, so recognize the emotion of a person and generate content related to that. So this is very much machine perception. Image and video segmentation. We have also, with respect to computer vision and machine perception, we have a lot of work with autonomous vehicles and partnerships with big companies like Bosch, here working together with Bosch in Portugal. biometrics and forensics, medical image analysis, multimedia content understanding, multimodal and semantic data processing. So all of these pretty much related with machine perception, which, as you remember, these two domains, machine perception and communications, evolved separately since a long time, and we still have, of course, a strong presence in these two domains separately, but now we are combining them in the same direction. Regarding microelectronics and reconfigurable hardware, we have people working on algorithm-specific hardware design, like FPGAs, ASICs designed for neural networks and neuromorphic computing, which is the new trend, let's say, to imitate the human brain regarding computing, and we have people working on that, and also in-memory computation using thin-film electronics. When it comes, and just the last part, so when it comes to wireless communications and networking, we have expertise and also doing work on design of antennas and microwaves and radio and microwave devices, modulation formats, which is something that will come up or will end up very important for next generation networks, optical propagation and signals processing, radio over fiber, and reconfigurable intelligent surfaces, as Luis just mentioned in the panel. We are leading one of the European projects in this area, where we will be developing these type of surfaces that will change the way we communicate, because so far we just touched the endpoints, so the transmitter and the receiver, and now we are touching the channel with this. So this is something that we are very involved in and which will change the paradigm in 6G and also in related technologies. And finally, on networking side, for using wireless as the underlying communication, but focusing more on the networking part, we of course pursue autonomous communication networks, and this is where we see, for example, the combination of machine perception with the communications part. These networks, to be autonomous, they need to have a lot of machine perception to understand where the nodes are, who they are communicating with, and so on. Also, doing communications for extreme environments. We have been working a lot as it was also discussed in the panel, regarding underwater scenarios, airborne scenarios, disaster management scenarios. And one thing that is becoming a hot topic in the community is network digital twins. So we discussed a lot here today about digital twins in general, but the networking community is looking at digital twins as one of the ways to build and design better networks on top of it. And we have a strong work since a long time using the Network Simulator 3, open source simulator. And all this converges, by the way, and the name of the project is the same, converges to this European project that we are leading in CTM and involving all the scientific areas that are part of CTM, and under this motto, view to communicate and communicate to view, and I would maybe change it a bit and say perceive to communicate and communicate to perceive. Because I think maybe not in the project, but maybe in the future we will add new sensors and new other types of input information that will let us communicate better and also perceive better. And so the idea of this project is to develop convergence tools for research infrastructure. So it's not a research project by itself. It's something that will build the tools that will enable the community to innovate in the future with respect to these conversions. So just to finish and not to take too much time. So in conclusion, I would say that convergence of these two areas is happening, is starting, but it's happening. And it will come up for sure in 6G and next generation networks. And it will impact for sure multiple verticals. I have there some examples: communication networks, of course, robotics, smart cities that we discussed a lot here today, utilities, and you name it. So any vertical that you might think about will depend on this merge. And we believe that CTM is at the forefront to invest in these conversions because we have the skills, we have the competencies inside to do this. We have the critical mass as well. And we have target research areas, we have the projects running and the partnerships that are adequate to do this. So, get involved driving this and partner with us. Thank you very much.
Thank you very much, Rui, for sharing with us CTM's vision and the work that is being conducted. So we are now entering the final phase of this first part of our event, and I am honored to invite Professor António Cunha, President of the North Region Coordination Commission, to give us the final remarks on this event. Please, Professor António Cunha, the floor is yours. Thank you very much for your presence.
Good afternoon, ladies and gentlemen. It's a pleasure to be here. I'd like to greet all the colleagues and friends in the audience, and of course, in a more formal way, José Manuel Mendonça, by the kind invitation to address you in this open day of INESC Tech. I'm going to try to mix some perspectives from the regional management, the territory management, from some of the challenges you are facing and some of the activities you are, of course, involved. I will do that with some context, but I would say a very well-known context, both in the world and in Europe, but really I would like to focus in the territory, because in the end of the day, it's in the territory where things happen, is in the territory where people live. Of course, the world goes digital, you know this very well. Of course, digital transformation is of course, a lot about different types of technologies, of making capacity of making mimetics of the reality, making digital twins. But what I'd like to take is this more simple idea that, in fact, digital transformation is about new ways of interfaces between machines and humans, and of course is about new business models. For companies, of course, it's very, very important to be acquainted with the technology and to have capacities in technological terms, but really what is important is to be prepared for the new business that digital transformation is enabling. For instance, when you have products that communicate with the customer, products that can have the customer have a completely user experience, and you can have even a feedback of what your product is and the service you can mount on top of that. So from the business point of view, of course, the new business models is something that is really the big change, the big challenge of the digital transformation that we are involved. And of course, all of you know, and much better than me, that all sort and huge developments will going to happen due to AI, that we are really beginning to open a door that will open surely new frontiers. So this is a well-known environment where we are, where academia is, where research centers are, but where also companies and society are. By other side, we know that the world is warming up, things are heating, this is happening, and of course this is having consequences, consequences that we can feel. We can feel here in the region. The harvest in Douro Valley is now 1 or 2 or 3 weeks later than it was before. The impact of the climate change, both in vineyards or in chestnut trees is quite evident. So nowadays we don't need to make a big effort to look for evidence of what is going on. And this is why there is all this pressure for the world goes green at international level, but mainly at European level. This is a movement, this is a way to go, this is a way to interpret the future that really is being led by Europe. In a certain way, I like to say that one of the consequences of this development is that the world also will go electric. Of course, will go electric by sure in mobility. I think INESC will be able to give a practical idea of that concept of NASA, of the electric plane, but that is over there, but someone will develop it, but by sure this will happen. Yes, we have now quite an important agenda in renewable energy, an agenda in the territory, an agenda in the ways we produce energy, an agenda in the way we manage and distribute energy with the smart grids, where INESC is also a reference institution. And of course, no matter if we will use more or less hydrogen for trucks or for mobility, by sure we will use for heating devices in industry, at least we need to use hydrogen for storage in the energy, and hydrogen, green hydrogen, will be present in all this equation. Yes, the world goes green and will goes digital, and this is something that we need to realize. And for instance, what this means for Europe, this means that, for instance, the regional program of the North 2030, the North 2030, has a budget, and that budget is mandatory, that 40% of that budget is for digital transformation and 40% is for green sustainability. So these are not rhetoric figures. These have consequences in our practical life and in the way we manage European funds and public policies. Energy, of course, will be in the center of this equation. Energy in mobility, as I referred, energy in houses. We have mainly in the north part of the country where temperatures are lower, significant zones of what we can call energy poverty. The insulation are not good, so this is an area where much attention should be made. But everywhere, and even things like a simple T-shirt that our textile factory, our textile industry manufacture, now this is already under the European legislation, we'll have to have a kind of identifying energy passport or environmental passport, where it will be revealed what is the energy consumption. In fact, this is a nice example that I'd like to bring to here, because textiles, that is still important for us and is important for us, will be an industry under a very, very severe pressure because of energy consumption, but mainly because of water consumption. The amounts of water consumed that are consumed for instance, in produce a very simple white cotton T-shirt are huge, and this is under a tremendous pressure by the European policies. I will be back to this subject later, but yes, so these topics are addressing quite developed industries, or more what we normally say and call traditional industries. Of course, in the last years, the world has changed almost twice, because it changed one first time because of the pandemics and several developments in what we call we can call a low-touch economy, but also mainly in logistics. Now, global logistics has been in some way reversed, and we speak more in terms of regional logistics or continental logistics, and things have changed. And one of the, perhaps of the most paradigmatic examples is the problems that we have been facing with the so-called ship crisis. But this was an important change, but we had another one, and in fact, the world also changed, and Europe is changing because of the war that we have in Europe after the Ukrainian invasion by Russia. So, in fact, we have a new order that is a process that was coming from the digital transition and the energy environment transition that was already going on, but now by these new developments associated with the COVID and war that really are causing big transformations in logistics, drawbacks in what we call globalization, and forcing or promoting more nearshore approaches, and of course, all of you know the questions of the cost of energy. What this has to be with us or with the society is that in a certain way there are several issues very important for this audience, also for companies, for political administrators, that things like energy, things like manufacturing, things like food production and agriculture are not anymore just economic issue or environmental issue or business issue, and really became and are more and more sovereignty issues, and so they had a reinforced priority, and they are in the center of the European policy. How Europe is trying to address this is trying to address by two ways: by increasing, strengthening knowledge and knowledge that produce technology that is able to address these topics, and of course always under what is different here from other parts of the world, under a very demanding environmental sustainable agenda. Developments, you know from where they will come, by sure from digital, by sure from materials, by sure from biotech and all related with genomics and things that are developed from that side, capacity of engineering or editing life, and by sure in the future also by quantum and the different opportunities that is opening, namely for sensing, but also for communications and computing. Once again, technology is important, is very important, but business models perhaps will be the biggest change. Perhaps by sure we will have one day a completely autonomous car, perhaps until the end of the decade, by sure. But more than the technology developed, the intelligent developments associated with the autonomous car, what will change completely business and companies is the business models behind the autonomous car, because perhaps we don't need to have our car, we will just rent a service. Who is going to win this new business is going to be companies like Google or Amazon, is going to be companies like Mercedes or BMW. This is quite an open issue because the business is going to be completely different. And once again, these business models are happening in, so let's say, high-tech areas like autonomous car, but also in, once again, textile industry, where circular economy is going to be a demand, and where really now the concern is about the very reduced number of times that majority of people use a certain cloth. And what is going to happen in the future, by sure, what is now already happening, mainly in fashionable and in fashion suits, mainly for ladies. This is not gender comment, but is that nowadays in socialite magazines it is not very keen that someone will show the same dress twice or 3 times, and in the future it's going to be very politically correct that saying that certain personality have used that dress already 10 times because this is very good for the environment. So this will change completely the business, and once again, things like renting clothes will be perhaps more normal than is today, and this will, once again, this will change completely the business in the way the business is made today. Of course, there are another important area that I would like to bring here, that is the so-called democratization of the space economy, and the space is not anymore an area only for countries, for national agencies, is already being addressed by companies, by private companies, and several services are in the business pipeline associated with space monitoring, vigilance, different types of monitoring of forests and other areas. Okay, what this has to be with this rectangular north part of Portugal, the north, as you all know, 3.6 million of people, 22,000 square kilometers, so 36% of Portuguese and 28% of the Portuguese area. We have some figures, and we are comfortable with these figures because we are, yes, in fact, 35% of the population, 44% of the companies, 33% of the R&D. We are, okay, comfortable with this. We are happy with this because we are 48% of the exports. We are really an industrial zone, or really a manufacturing zone. In fact, we are one of the 10th regions with higher density of and higher weight of the manufacturing industry. We have a trade balance positive with a surplus. Our regional innovation system is interesting. So yes, we are happy, but we are not happy at all with these figures, because although we are 35% of the population, we only represent 30% of the Portuguese GDP, so value is not generated here as it should be. Poverty is higher in the North region than in the other parts of the country, because this is one of the regions where we have a higher percentage of people receiving the so-called rendimento mínimo, so the social income. And in fact, we are the only region in Portugal where all the sub-regions, including the Porto metropolitan area, are they have a GDP per capita lower than 50% of the European average. This doesn't happen in any other region in Portugal. In Centro, the region of Leiria is above. In Alentejo Litoral is above. And of course, metropolitan area of Lisbon and Algarve are above the 70% of the European average. We face several challenges, including the demographic one. In fact, in Portugal, Lisbon zone, Lisbon and Tejo Valley and Algarve are increasing population. The others regions are losing population. Centro and Alentejo are losing more than North, but even so, we are losing. And if you see mainly in that municipalities that are in orange, yes, we have a positive evolution of demographics, but in the others, in the blue ones, we have a negative evolution, and in some cases, this can go above 15%. Of course, North is very different in terms of the density of population, because it varies between numbers around 10 people per square meter to in the inland of Trás-os-Montes or Alto Tâmega to figures like 5,000 here in Porto metropolitan area. We have significant, we have zones with significant percentage of population considerable with vulnerabilities, economic loneliness. Of course, in absolute terms, they are in the more populated zones, the numbers, but in percentage, you see those dark blue zones are the zones where this problem, are the territories where this problem is more severe. We have exports and that value generation very much concentrated in the littoral bank, in the territories of Área Metropolitana do Porto, Cava and Alto Minho, mainly also in the Alto Minho border across close to Spanish Galicia. This is more or less aligned with productivity. The zones with darker green are the zones with higher productivity and also with the average salary that you see are the spots in red and yellow where the average salary is higher. In any case, the average salary is lower than in the other parts of the country, like mainly in Lisbon. And when you compare, for instance, an average salary from North region to Lisbon and Val do Tejo region, we are speaking of difference that can go up to 25%. Why is that? There are several explanations. One was in the past the low level of education of the population here in the region. This is not anymore the case. Now, if we speak about the population in the cohort up to 30 years, and mainly in the cohort from 18 to 25 years, the North has the best scores in Portugal, and although Portugal improved a lot in the last 10 years, the major improvements were made here in the region, and so we were the less developed region in that regard, and now we are the region with best figures on that domain. But of course, the situation is completely different if we speak of the population over 40 years old, where our levels of education are much lower. And there are different ways how this is revealed. One can be picked up by this nice atlas for complexity from the University of Harvard, where you have a pictogram about Portuguese exports, what Portugal is exporting. These are 2020 figures. Yes, and Portugal is exporting what you can see over there. But when you compare this with complexity, and the complexity in this case is normally associated with the add value of the products, and so low complexity is brown and high complexity is green, you see that where we have our major exports are in the zones of low complexity, and we don't export so much in the zones where added value here. So this is our challenge, is to migrate to added value zones. This is happening if we compare the type of exports, for instance, in automotive medium high complexity products. It's increased a lot in the last 10 years, but what we are, the way, the velocity, as the speed as we are ramping up in this challenge is not enough for the challenges we have to face. We, of course, innovation is one of the key issues for this, to address this challenge. North region recently was awarded in Brussels in an event of the European Commission, because in the so-called Regional Competitiveness Index, North is one of the European regions that is increasing more during the last 5 years. In fact, is the non-capital region that has increased more. The first one is Warsaw region in Poland, but is a capital region, and normally the capital regions are always more performant, but the second one was not. But, and is very clear then that positions, that scores that we have, they were based very much on innovation and on exports, and this is, of course, one area that we have to continue to develop, to strengthen our innovation system. Once again, is very unbalanced. If you compare this graph where we have our higher education systems or research centers, innovation centers, they more or less correspond to the zones where the exports were coming from. Of course, we need to have a better regional territorial balance of this innovation ecosystem. And another reason for identified by the European Commission for our good performance was we have been one of the regions more strictly adhering to this specialization, to this smart specialization, and so we have been trying to be very selective, or not very, or rather selective on the projects that we are approaching. And in fact, so the smart specialization strategy is something that should be strengthened. These are the areas that have been revised for the new European framework. They are not so different from the ones in the past, but so these are our 8 domains where we are structured. This is very much linked and connected with our new strategy for territorial development, the so-called PROT-North, one strategy that is being developed with several contributions of several stakeholders in the region, including Inesctec. There are a model behind this new territorial approach that brings what we call differentiation factors, and so giving us an emphasis and a special focus on these 4 factors that were considered as critical, namely water, energy, carbon neutrality, and demographics. And is under this scope that so we intend to apply our regional specialization strategy in the areas that are expected, because in the areas where we have our industrial structure, of course, in the digitalization of the economy, no matter if it is in the domain of the manufacturing systems, the health systems, the agro-food systems, or also in this domain of the relationship between technology and governance. And of course, we can be speaking of the industry 4.0, of the precision of agriculture, smart cities, digital medicine, or fine tech. Of course, in areas normally called as traditional industries, but in fact they are new traditional industries because they are more and more technical with high technology content, namely in textiles, both in shoe industry. But yes, they are putting several technology challenges that are being addressed by several research centers, by several universities, and this is a critical part for us. Textile industry is still very, very important from the social point of view. We have quite an important number of people employed in that industry, and with age above 40 or 45, that transition to other economical activity would be very, very difficult. The automotive or the new automotive value chain is a critical area for us. Is a critical area for us if we consider only The North region is a critical area for what we call the Euro region, the North region, and Galicia. Together we made one of the most important spots for automotive industry in Europe. One of the biggest European factories of cars is the Stellantis in Vigo, and this ecosystem here is very, very important. And more than that, is an ecosystem that is very, very oriented to the future, to the car of the future. Here we manufacture all the inside electronics for panel clusters. Here we manufacture radars. Here we manufacture different type of sensors for automotive functions that for autonomous functions that present cars already have, but for new functions that will have in future. Name also safety. Major European producers of airbag systems are in Vila Nova de Cerveira and in Ponte de Lima. So this is a zone where we have very nice companies associated with this area, and all the developments that mainly the Bosch Group, but also Continental, also Aptiv, are being developed in the region are critical for our development, once again in a straight cooperation with the other side of the border with our Galician brothers. We expect really to put together the lithium value chain. We will have lithium exploitation. We will not have lithium refinery. The projects that were approved by the government are not in North region. Of course, we don't have also chemical complexes, but they will be so in Estarreja and in Setúbal. But we hope we will be part of the business in the end of the batteries manufacturing. Once again, here or in Galicia, by sure, some things are happening, and normally when we have a big investment in Galicia, we also benefit because the proximity is a key issue for that. In this house, I have to speak about energy, about renewable energy. North is responsible for almost 50% of the capacity that we have in Portugal of renewable energy. Hydropower is very important for us, but also the eolic is not negligible. This is information from Tech. What is interesting that we have here is really a very good mix. We have almost every source of energy, and when we speak of renewable energy, really what is important is to have different sources depending on the environment condition, depending on the demand, we will be able, or the grid will be able to answer, and we'll have a capacity to answer variations on the demand. And so North region has that capacity, that potential, and by sure this will be also a way of putting the region more attractivity, with a more higher attractiveness for industrial environment, because you can have here, or at least you can expect to have here a higher content of renewable energy in the energy that you are using. Several key recent environment projects, for instance, is this one of what we call the giga battery of the Tâmega. This is a very interesting project with 3 dams, and since the beginning he was designed for continuous use of the same water several times, because he produces hydropower energy when it's coming down, and is pumped up with based on eolic energy that is used mainly during less demand periods, namely in the night, and the efficiency of this system is very high, and this of course is one idea, is an example of how these systems will operate in the future. We are by now the only town in Portugal with this project on offshore eolic energy in Viana do Castelo with these 3 windmills. We hope soon we'll open the international bid for these platforms here mainly the one that is going to open is the one in Viana do Castelo. We'll have another one here in front of Leixões Matosinhos, but so this will change completely and will reinforce a lot our capacity, namely also this project that I refer about, the Tâmega. This is only part operational. This until the end of next year will be full operating, and our capacity to produce renewable energy will increase a lot. Several other projects are going on, namely in Alto Rabagão, some pilot projects on floating panels, and also this nice project in Chaves about already working with 3 hotels and several buildings that are being heated up by geothermal industry. From the point of view of someone that is responsible for regional planning, really one of the critical issues we have now is energy transportation. No one wants that the high voltage cables will pass through their land, through their territory, through their municipality, and so this is a key issue for us. I expect that INESC engineers on high power will develop a different way of transporting energy that will enable us to solve this. For us is also very important the agro-food system. In terms of business, agro-food systems is a very broad area, but I would say wine and olive oil are, of course, the major products, and also what we call frutos secos or dry fruits, namely chestnut is a key production for us. We have 3 municipalities that live on chestnut: Vinhais, Sernancelho and Valpassos. Their economies are based on chestnut. Once again, chestnut that in some cases is the added value is added outside of the country and not here. So this is a nice example of how we should improve. Tourism is increasing a lot. We are the region in Portugal with higher percentage of increment in the tourism, although all the country is improving. We have five UNESCO sites. You can recognize them: Guimarães, Bom Jesus in Braga, Porto Downtown, Coa, Gravuras do Coa and Douro Valley. And we hope soon we will have another one, the so-called Geira Romana, the Roman road in Jerez National Park that was part of the ancient road from Braga to Astorga, and we hope this will be classified soon by UNESCO. The other area that we have on our domains is this area that we call technologies, governance, economic and society. The issues of equity in the access to digitalization is something very, very important, and the ways how public administration that is being more and more digitalized is going to be used and is going to interface with people that has almost no digital literacy. This is a challenge in some of our remote regions, and of course also inside this topic, everything that relates something that by sure soon will be a political issue. How is the relationship between machines and humans, and what can be done by machines and what will be not be allowed machines to do. This is by sure will come in the next years in our political agenda. To finish, carbon neutrality is an important issue for us. Also, quality of the air and different ways of using technologies, including satellite, to monitor quality of the air. I'm going to finish almost with this slide from a very interesting work that is going on trying to compute carbon balances in the region, and based on computing emissions and absorption of carbon, and also the stock of carbon, and having a kind of an hybrid figure that will give you a global computation of this. And really, I'm just putting here some conclusions of this work. Really, we have 3 different zones in the region. One zone where is the industry, where is the urbanized, the big cities, where we have a higher amount of emissions and the lower carbon stocks, of course, in the territory. We have an intermediate zone, we have low emissions, but we have high carbon stocks. In fact, the carbon stocks, they are more storage, they are better storage in the land than in the trees, and so you need to have a certain type of soil to have a good carbon stock. And we have a zone that, mainly because the soil is very poor, because the soil has been destructured and destroyed by also some drought that already is happening, where we have low emissions and low stocks. And so this enables us to develop some policies, like, for instance, what we have here, that here in this littoral urbanized zone, the objective is, of course, to reduce emissions. Over there is protect the stocks in that intermediate zone, and to increase sequestration and use techniques for increased sequestration is, of course, the strategy that should be used for those lands in Douro and Trás-os-Montes territories. Okay, just to finish, yes, we are very much on this agenda, on technological agenda, this agenda of digital transformation, a digital transformation that has to be done with environmental sensitiveness, but very much real. This has to be integrated, this has to be coupled with these key features for our territory that we considered: water, energy, carbon, neutrality, and demographics. And in fact, for instance, to finish, in the next 10 years, we will need to have a huge revolution in Douro Valley. We need to wet the Douro vineyards. If we don't do that, perhaps we will not have production of wine in Douro Valley. So these are the big challenges that we have ahead of us, and this is why knowledge and technology is very important. Thank you very much.
Thank you very much, Professor António Cunha, for this presentation, drawing us the attention for all the environmental, societal, and economic problems that we are facing, and to challenge us or defying us to use our technology in order to find solutions for that. So we are now arriving to the end of this first session. So I thank you all for your participation on behalf of the organizing committee, and I hope that you have enjoyed and profit from all of the fantastic presentations of our speakers, to whom I thank again their presence to make this event so interesting. But we are not finalizing yet, so we have a second part, a more participatory part. We invite you for a cocktail. Well, you will have also the opportunity to see some demonstrators of CTM that showcase the research and the work that we are doing in our research center. So thank you all and enjoy.